does gravity make the Earth a ball? Because I'm okay with mass attracting mass. There's evidence for it. It's very little, but there's evidence for it. I'll give it that. Um, Whether it's proof or not, I don't know, but let's just go with it. Mass attracting mass, right? I have no problem with that. It's the second half of that statement. Attract Mass attracting mass, comma, pulling inward towards the center of mass. That second half is what I have a problem with. How do you get evidence for pulling inward towards the center of mass? How do we know it's pulling inward towards that? And so that's why I'll say, okay, I'll grant you gravity. Does gravity make the Earth a ball? If they say yes, cool, let's go measure for the curvature. If they say no, okay, well then I agree with you. Gravity is mass attracting mass. You can have gravity on a flat Earth.
Surely by now we should have something better than the lateral attraction that they've got in Cavendish. Can we not have something that is actually, well, gravity pulls in all directions, mass attraction allegedly, so can we not have some sort of test like that? But then, how do you isolate that from Earth's so-called gravity? It's all nonsense. It's smoke and mirrors. They're trying to put Cavendish onto this downward attraction, and it's a lateral attraction, and it's a pile of nonsense.
Well, the whole Cavendish thing, that wasn't his purpose in that experiment to begin with, even if you called it an experiment. It was to find the mass of the Earth. It had nothing to do with gravity.
Yes, sir, exactly.
Sheepdog.
The whole Schehalian thing. Yeah.
You had said that there is proof for mass attracting mass. What is that?
I would say evidence. I wouldn't really say
what is
proof,
the evidence?
right? Like if you've seen those videos where they have a mass object, right, and a weighted object on a scale or whatever, and then they slide another more massive object underneath that weighted object, and then it pulls down just a little bit more. I mean, you could call that evidence. I'm okay with that.
Okay, I don't think
I'm not following.
I've seen what you're talking. Yeah, me neither.
So yeah, so they'll like put a little like 5 gram weight, right, or 1 gram weight on sensitive scales, right, and then they'll get a huge ass like 10 kilogram or 100 kilogram weight and suspend it above it, right above it, and it lowers the weight of the 1 gram object sitting on the scale.
Yeah, right.
Yeah, I call bullshit on that too.
Yep.
I'll find the video. Hold on.
I need their margin of error. Without it, they don't have a measurement.
And everything else that they put in there to cancel. You know what I mean? There's other variables also.
Yeah, I mean, I've got no problem with gravity either. I've said it before. Like, I've been open about it. Like, I'll just say, like, gravity is the unknown reason why matter distributes itself the way it does, right? But I don't think that it's exclusive. Like that, I don't think there's necessarily this idea that, like, it's an interaction between matter and other matter, or it necessarily between matter and space, right? Like it could be something completely different. And I don't think that it's affecting all states of matter equally in the same way, like whatever it is. Like I still refuse to accept that there is some kind of invisible force acting from solids and liquids on gases and gases upon each other themselves. Like, I just don't see that evidence. So if there is something like a force or a reason, some sort of intrinsic, a reason that we don't understand yet why, the denser goes towards the bottom and the less dense towards the top, right? I don't think it's fully understood, and I don't think it necessarily affects all states of matter. We see it very evident in solids and liquids, but not gases. And plasmas is another thing altogether, right?
Yeah. So when you have objects like solid objects, in this instance, discharge, the idea is they're shedding electrons, and they actually do weigh less. It's charged a discharged object does weigh less than a charged object.
Yes, yeah,
Right.
absolutely.
Yeah, you got energy to contend with too, right? Yeah.
Right. So if their margin of error in this case by pulling a big weight over a small weight and it weighs less, I mean, if their margin of error falls within the allowable tolerance of a sharing of electrons,
Exactly.
just for example, then yeah, you can't say it's gravity, even though it does weigh less.
100% Yoder. That best said right there. Because
Thanks.
I've been reading that book, that Electric Universe by that dude back in the. Well, I haven't been reading it, but I've been looking into it a couple times. That guy back in the 80s that wrote it. Oh fuck, I forget his name.
I think NASA's really into that. Honestly, the behind closed doors, it's all plasma and electric universe stuff.
Right. Well,
But
then
it's treated
you
like
have
it's
problems.
poppycock on the outside. I'm sorry. Go ahead.
Right.
Yeah.
No, I'm agreeing with you. Yeah, for sure.
Did you see that new guy that was? He's appointed at NASA as like head of like electrostatics or something like that. I was watching a video the other day about him.
Really?
Yeah, and they're talking about like that being the future of their propulsion now.
Yeah, they've been more open about it, but they've been doing this since the very beginning. I pulled down electrodynamic tether tests for propulsion and for station keeping and stuff up in space, going back to the 1970s from NASA. They don't talk about that. They're acting like it's new.
Yeah, they're acting like it's new, and then like he's now the foremost expert on this, and like he's doing the rounds a little bit now. I'll see if I can find a video.
That'd be cool. Here's a
Well, I'm
guy,
sure
a
there's.
NASA-affiliated scientist named Hannes Alfvén from Sweden, and he is credited with creating a whole new field called magnetohydrodynamics. And that's all what this is.
Interesting.
Yep, he's Electric Universe, and he's I think long passed away. Like he was active in the 1950s with this stuff. Yeah, basically using magnets, magnetic fields, the force is like a machine to drive work, to do work. It's like the real life Magneto, honestly. Hannes Alfvén. So I've talked about this before, but I came across a paper in this server. It was shared with me called "Double Layers in Astrophysics." Describing the exotic environment above our heads. And the paper includes a device, a laboratory device that they built to simulate the effects of space, so they could, I guess, study the models and hope. Oh, sorry, I think you lost me there. So anyway, Double Layers in Astrophysics was this great paper that Hannes Alfvén was an author. He co-authored it. He presented it to a panel in the 1980s, and he was just shaming like the entire panel of astrophysicists. He's basically saying, you dummies are studying like gravity as the primary force of outer space. You have no idea what you're doing. I would not trust the $1 billion Hubble Space Telescope data to a bunch of morons like you. Instead, you give it to people who study plasma physics and circuit theory and electromechanics and all this other stuff. But you gravity dorks need to take a backseat to all this. That paper's in here, and so is that beginning introduction. It's pretty good.
I'm looking for it. It was like a podcast or something like this, and I think it was Julian Dore or something, and he had Bob Lazar with him, and because he had Bob Lazar with him, and earlier he had this NASA scientist with him, he got them to talk on the show. It was very interesting. I'm still looking for it. I can't find it. Okay, I'm finding it. I found a clip from it. It wasn't that guy. It was some different guy. It was Jesse Michaels who was talking with him. I just been watching the other guy, so I superimposed him in my memory. But I'm almost there.
Yeah, and NASA's even saying that the electric field is they're putting it right alongside the fundamental force, alongside gravity.
I'm still looking for it, man. I've seen this video before where like they have this object dangling from a scale, and then they take another massive object and they move it across from one side to the other. And when they move it directly underneath the object pulls down just more. Now, whether or not it's charged, I have no idea. I thought it was a bowling ball that they moved underneath it, or just a large, more massive object, like maybe a lead object or something like that, lead ball. Um, but I mean, that still leans more towards what you're talking about, having more electrons, more weight. Which I actually somebody mentioned that it was one of the guys that we talked to on X. Name was Jonathan. He said he knew of a guy that's like he bases his entire theory of gravity on electrons. Like the more electrons something has, the heavier it is. And I thought that was fascinating, but I don't think we ever got a name for him. And the last I heard, he hates talking to flat earthers about it. Like, why? I'm so curious. Why? But I'll keep looking for the video. But if it sounds familiar, I'll stop. I'm looking for it. I know I've seen the video before. It's stupid. It's a weight, right? Like a small weight object dangling from a scale, right, on a string or a spring or something like that. And then when a more massive object passes underneath it, it pulls it down just a little bit more on the scale. The distance, I don't know how far away the distance is. So it could be close enough to have a electron discharge, if that's what you want to call it.
bet he hates talking to flat earthers about it because he don't like people that ask questions. He just wants someone to nod and agree.
Well, I guess this turned into a home server event. Anybody got event powers? Want to make an event out of it?
Yeah, I'm running away again to do the things I need to do. I just was laughing at McLoon and wanted to add this electrostatic stuff. Witsit is probably having a field day citing current NASA.
Yeah, it's funny how they're like slowly rolling that out, and then the people that have been at the forefront making the argument for what they're rolling out right now is anti-gravity. Witsit would argue they've had anti-gravity forever, for like 80 years at least, and now they're just now rolling it out, and everybody's going to jump on board and say, look, that's what anti-gravity is, and like completely ignore what they've been listening to for the last 10 years. Hey, Drace, you got event powers? You want to like kick off an event for us real quick before you go?
Yeah, let me see if I know how to do that. How do we start events? Is it here? Create event. Let's figure this out real time. What is your event? Voice channel. It's in live stream. That's where we're at.
I need to learn this, so this is good to see.
Yeah, I'm just figuring it out as we go. Next, the event topic is Adnan.
Ow.
Which came first, the ball or the idea?
That's a question. Chicken or egg?
Yeah, I don't know. And then frequency. Do not repeat. Tell us about your globe beliefs. It's a description. Put no image. I think I create the event. Ta-da! And this is the invite to the thing. I think it works. Oh, I messed up the time somehow. There we go. Now I fixed the time and started it manually. Woot.
Appreciate that, man.
Thanks, Shinobi. Hey, can I bring someone in the chat?
Yeah, man, what you got?
All right. Do this for about 45 minutes. I got a 45-minute one. Let's see. And I gotta go. Hey, brother, what's going on? One second, I'm just gonna mute. Live restricted says I can. Cool. Yeah. So if you want to explain your position to the Flat Earth crew, yeah, that'd be cool. Yeah. So I'm Duden's Story. I'm on TikTok, and my main thing is I'm not trying to convince people that the world is a globe, and I'm not trying to think that you're going to convince me that the world is flat. I want to know why you think what you think, not the evidence or the perceived amount of evidence or whatever it is, but given that there is this massive abundance of evidence and experiments and explanations for why the world could be a globe or should be a globe or is a globe, what is it? What are your reasons for rejecting that evidence?
The evidence is why.
Because of certain other
I don't get it. The evidence is why. How do we say why when our why is evidence, right?
Yeah, he says we can't use evidence, but he can.
Right.
Oh, wait. I'll address it within his frame. Okay. So we're not use our own evidence, because that's not like I didn't know about the flat Earth evidence in the beginning. I just knew about the globe, and I wanted to believe in the globe, and so I looked at all the so-called proofs of the globe, and one by one they fell apart. None of them actually holds any water. Most of them are fallacious appeals, or they're stacked assumptions. So those are not actually proof or evidence of anything. And so that's why I felt forced to try to validate the globe for myself by testing the claims. Not because I wanted to be a flat earther, just because I wanted my belief in the globe to be true.
Well said, Drace. I agree with that. That's my contention too. I looked for what people said was evidence for the globe, and I couldn't find it.
Hold on one sec. Yoda. Experiments for the points. So is there something? No, you can go, brother. I was just saying, for every one of the points of evidence, and I've been on lives with a lot of very articulate, very well thought out flat earthers, and it always comes down to, at some point, a rejection of the evidence that contradicts what you feel is proof of your standpoint. So that's where I'm saying, like, we can get down into the evidence, but realistically, there are more experiments and explanations for why it's a globe versus flat Earth. So I guess where I'm like, is it because of you only believe what it is you can experience yourself? Is it because you have a distrust in the authorities that are presenting the evidence? Is it because like that kind of stuff where it gets deeper into it?
No, your premise is wrong.
Bingo.
I'm just giving options. I'm not saying any of those are your reasons. I'm just asking what
you're giving.
I guess you never talked to us.
You're giving.
Yeah, you're claiming that there's more evidence for the globe. However, we've gone through all the evidence. You have not gone through all the evidence, nor have you gone through all of our evidence. So you're sitting there saying there's more globe evidence, and you've never looked at it. Meanwhile, we looked at all of it, and we want there to be some globe evidence. There just isn't.
Hold on, dude. Just let Drace finish, and then you can go on. I know it's all good. So, Drace, you want to finish?
the
I'd
end was
like to
just we
append if this
wanted
guy
there to be
thinks
globe
explanations,
evidence.
a force of an explanation drives evidence or the truthfulness of a thing.
Oh,
Neil,
yeah.
just let me
So
know
Yeah,
when
you're good, bro.
Yeah, does
Okay.
so
a good explanation
Let's deal
make
with, like,
for
if we're
more
gonna talk about
truthfulness?
evidence and experiments and stuff, there's a lot that you can be like, you can only infer things from some experiments. Because I believe, like, there is no single experiment that proves anything about the globe as a whole. You have to kind of create a web of experiments that all rely on each other, right? Except for people have
what
gone into space
experiments?
and sent photos and videos. So do you
There are
trust
no
videos?
experiments.
That's a true statement.
There are no experiments proving the globe or proving aspects of the globe. None.
There are also no globe measurements.
I
We
can mark
checked and we
that proving
understand how
aspects
that
are
was
not the
crafted.
globe theory, the heliocentric thing all together. I agree with that.
No experiments, no measurements either of a globe.
So what about the last part I was saying, though? Like, spaceships have gone out into space, sent back photos and videos.
Oh yeah, why do you accept that's
Deny
true?
that happened.
Why do you
You
accept
believe
that's
that?
true?
Well, that's what I'm asking you. Well, I
Why
believe
do you
that because
accept it? Yeah,
to
like
me
do you
there
auto
is
believe? Do you auto
broadcasted
believe because you
information.
trust?
I've known people personally that worked on the
Oh, for crying
projects.
out loud.
There's a preponderance of evidence saying that
Dude
this
just
is
wants to
what
preach.
is happening in reality. And so my question to you is, why do you reject that happened?
Why should we accept it automatically?
You shouldn't.
So I have nothing to reject.
Have you tried to prove that it did happen, or prove that it didn't happen?
Very
Are
easily,
you reversing the
because
burden on me? Hold on, are you reversing the burden, dude?
Well, no, because if it is a thing that is happening in reality, and
How do you know it's happening in reality, dude? You haven't established that yet. I don't have a fact for me to reject at this point.
yeah, so watching videos of the rockets go out into space, watching the video of it being being able to literally track it using the tracking devices, people looking through telescopes and watching the rocket exit the atmosphere on its approach back to Earth.
Yeah, why does that convince you? It doesn't convince me. I want to know why it convinces you.
Knowing it happened. So
Yeah,
that's
I
why.
want to know why you're convinced that that's all true and real.
Because there's no reason for me to not be convinced that it's true or real. So it's showing me evidence this is real. I'm like,
I'll
okay,
give you a
that's
reason. I'll
there's
give you a
nothing
reason.
that it's not real. And if you believe there is something to show it's not real, that's what I'm asking.
Yeah.
Like,
No, you falsely claimed you have no reason. I can give plenty of reasons.
sure, that's
First
what I'm
off,
asking.
first off, reason number one, when I go out and measure the Earth, I don't measure the curvature that they show me in those images or videos.
Right, but that doesn't mean that the video didn't happen. It just means that the measurements might have different.
It means that the portrayal of Earth is wrong, okay?
yeah, that means that means you have a claim that you believe that is contrary to reality.
Well, no, because my reality is based on the measurements and the studies done by more than me, right? Like, and so I guess you could say that I am appealing to authority when it comes to expertise of others, and that's kind of where I was curious. Like, is that where it falls apart for you guys?
No, that's where it falls apart for you because you just admitted that you're incapable of evaluating the claims.
Okay, so let's take a pause for a second because since I
Yeah,
got
you
on this phone,
definitely need one.
like jumping down my throat, and I feel like I've been pretty civil, and so I'm good to not talk to you. Neil asked me to come up here and have a conversation. No, and I'm not discounting anything.
Come to our server in Discord and have the conversation. Don't do it like over
So let's just
devices.
take a breath and
Just stop bloviating and preaching to us.
So how
conversation. Let's just try to be a little bit more calm with each other. So
I'm trying to moderate my side. I'm sorry. So how were they being rude exactly? I just want to know, just for the moderator's sake, because I just want to know.
Here's my problem with it, right? He came in here thinking that all flat earthers are conspiracy theorists and are threatened by authority. And then he comes in here and he gets wrecked because of his appeal to authority.
It doesn't feel like there's an openness to want to hear my side. That's what I'm saying. I'll be quiet and wait for you guys to.
He didn't want us to hear his side. He asked us about our side.
Yeah.
Right? That's what the whole thing was about. He wanted to talk to us and ask us why we believe the earth is flat, despite the preponderance of evidence, even though we have evidence and he hasn't even looked at it.
Yeah, the evidence he doesn't want to address and wants us to ignore because he imagines there's evidence which we are willing to address, but he also wants to ignore and to make this kind of meta argument, which is a non-argument.
Legitimate points. Okay, so would you feel better if I gave you like the experiments and the evidence that I am familiar with?
Yeah, you can find anything you think is an experiment or you think is evidence and present that, and we will go over it one at a time, and we'll go over every single thing you think is evidence. We don't mind doing that.
Right, but I think you guys are misunderstanding the conversations I'm looking for. I don't care about debating whether the Earth is round or whether the Earth is flat. I want to understand about you as people. So I want to go down tabula rasa and be like, let's go through the Foucault pendulum. Let's go through the Cavendish experiment. Let's go through, Aristophanes sticks, and let's go through the Tower experiment. Like, I don't want to do that because that happens everywhere. I'm actually interested in you as people.
You don't want to do that because your side gets proven false every time.
This is what I'm talking about. I'll meet this one. So essentially, you want to know what like flat earthers eat for breakfast, and like what what kind of car they drive, or like.
Yeah, that's irrelevant to the arguments, irrelevant to the topic. That's just an ad hominem in disguise.
So essentially, Drace AI gave you all of that in the start, right? He gave you his whole like epistemology. He literally said like word for word how he became a flat earther, right? Yeah, so you just want stories, but then all the stories lead into the evidence. Like, you understand, like, that's where the crux of the argument is the evidence, right? But you're saying that you don't want to look at the evidence, so I don't think there's like a further place to go with this conversation. You know what I'm saying? Because we want to look at the evidence, right? We're flat earthers because the evidence didn't line up, and we want to look at it. And you're like, okay, I don't want to look at it, but I want to know why you're flat earthers. And I'm like, okay, well, we just told you we have evidence. So, like, where do we go from here? Okay, so we'll go through the evidence, but let me just see if I can get the plan down. Most people don't feel passionate about something to go against what the 98% of the world kind of believes, because I think that's statistics. Like 2% of the world believes flat Earth, right? So most people don't have that much of a commitment to want to do that, and also make it so much of an identity that they would like want to do the length of research that you guys have likely done through this. Like, that's one thing I have noticed. Most people that believe in flat Earth have done such extensive research into it. And so I guess I'm curious, like, what is it about the flat Earth that inspires you to want to dive into it so much?
Evidence.
Considering for the most part, it's kind of inconsequential.
You asked us to explain why we're flat earthers without the evidence, and we can't do that because it's the evidence that makes us flat earthers.
I'll take another take at this, okay? So you brought in curvature of the Earth shown from space. If Earth is a globe, you shouldn't see curvature from the ISS. Did you know that? It's geometrically impossible, because from the ISS you're only exposed to about 3% of the Earth's total surface. Did you know that?
Yeah, that's why they use a wide-angle lens, so they can see more of, and that's why it also looks so curved from their
Yeah,
camera.
so
Right.
the curvature, so you're not seeing curvature from space. Of the globe, you're seeing curvature of the lens. So if the curvature that you're presented with is your evidence for Earth being a globe, then it's really not, because the curvature of the globe should not be evident in that image, only lens distortion, which you just admitted.
Yeah, I know. It's
All right, so lens distortion is your evidence of a globe, is that right?
ISS is photos.
If you're acknowledging ISS
I'm saying
was orbiting,
they've gone deep into space. They've sent photos and videos of the full entire Earth.
All right, so these launches where they show curvature don't go high enough.
The Artemis, it didn't go high enough.
Oh, so now Artemis. So wait, you didn't know Earth was a globe until Artemis?
No, I knew it back like during the Apollo missions.
Oh, Apollo missions. Okay, so you accept the Apollo missions.
Yeah.
In 2026.
Yep.
Based on what? Showing you the globe?
Yeah. So in my belief is that back in like what 250, 300 BC, when there was a first question about, hey, the moon gets a circular shadow cast on it during a lunar eclipse. I wonder why that is. And, Plato and Aristotle and Aristophanes, they started doing these experiments, and all the way through the 1600s with Galileo, like there were all these experiments that had to answer one little question about something. And they all deduced from that, based on the way that the measurements came out, that we are a globe and that we are rotating and that we are in a heliocentric system.
All right. So your claim is eclipse shadows, that they pondered eclipse shadows. Here's how I know you don't know geometry. All right, so you failed.
He does know history either.
Yeah, so he doesn't know history or geometry. Did you know that a curved surface?
Hold on. There's too much mic chaos. Do the thing. 20 seconds. Is that cool? Finish.
Yeah. So when the Apollo missions went and confirmed those deductions, it didn't seem like there was any reason to doubt that those happened, because they simply validated measurements that we've been doing for
You got this, Trace. I have to step back.
That's my statement.
Yeah, that's what you believe. However, there was not a consensus in ancient Greece that the Earth was a sphere in a heliocentric model. There was varying beliefs. The Pythagorean cult and its descendants had the cultist belief that the Earth was a sphere, and yes, they did assume that the Earth was a sphere by looking at eclipses and saying, well, Earth would cast a circular shadow if it was a sphere onto the moon, and so that's proof. Do you think that's proof, or do you understand logic?
Is one of the possible explanations, right? Like just the same thing, like Aristophanes.
No, it's
okay. Do not jump
impossible.
to the next. Relax, relax, calm down.
So that's what
Calm down. You don't need to jump to the next topic. It's okay. We'll stay on this. We'll stay. Relax.
You have to do another
Relax. Just breathe in.
Stay on one topic.
Holy shit.
We'll finish this topic before you jump to the next topic. Just like the last topic, like we hadn't really finished that, but like you couldn't prove Apollo, so you jumped to the next one. But no, bro, we'll finish that one. So, do you know that? Relax. Do you understand that shadows conform to the shape they hit?
See that's rude. That's what I'm talking about with the rudeness.
What is rude? You keep over talking me. That is rude on your behalf.
He's just asking you a basic question. What's rude about that?
Relax. I wasn't being worked up. I wasn't being rude. I was just letting you know.
Yes, you were. You were over talking me as I was trying to ask you the question instead of listening.
We're just moving on too
And so I
far.
asked you to calm down so that you could listen to the question.
I'm listening.
All right, Drace, you're up.
Do shadows conform to the things they hit?
Do shadows conform?
¿Perdón?
Dije, tengo que terminar esto, que yo mañana no vuelvo para acá.
¿Y terminaste? ¿Y salió todo bien entonces? Jamesy, you're hot micing.
Okay.
Oops, my bad.
Basic.
Shadows conform to the things they hit. Yes, they conform to the shape that they're cast upon.
Perfect. And so, if you cast a circular shadow onto a sphere, does the circle remain consistent?
Cast a circular shadow onto a sphere, the shadow would be circular.
So it wouldn't conform to the shape.
Well, if you're looking at it straight on, yeah, I mean, it wouldn't be a perfect circle. No, it'd be kind of warped. You're right. Yeah.
Bingo. Do we see that on the moon?
It would be kind of like an ellipse, wouldn't it?
Yeah. Do we see that on the moon? We would be kind of like a sine wave. It would stretch and distort along the edges. Do we see that on the moon?
No, because our perspective is straight on the moon.
No, we don't see that on the moon. So there's no evidence that this is a shadow hitting a sphere, but yet you believe it. Like, why?
Sorry, you asked me a question. Is that what we see? I'm saying, yes, that is what we see. Because our perspective is straight
Show
on.
us evidence.
It's not at an angle in which you would see like the shadow wrapping around the side of something. You're kind of looking at it straight on.
Yeah, you can test
Sorry,
this.
so what was your follow-up
You
question?
can test this, bro. Literally, you can test this. Taking a sphere, casting a circular shadow on the sphere. You could do it in your living room or in your bedroom, and you can watch as the shadow distorts along the edges of the sphere from your perspective. So your excuse doesn't make any sense.
The shadow's projected at an angle, not straight on. So yes, it would be sinusoidal.
So if you do where your experiment is, you like a basketball, and you shine a flashlight right behind your hand, which perfectly up the basketball, and you look at it from like kind of behind the light, so you have a strong angle of it. Your hand's not going to look warped on that shadow. It's going to look like a normal hand, but if you moved your head to the right or the left, then it would look warped.
I suggest you try it.
Livestream voice text.
Like we're right.
Sorry, I posted a GIF demonstrating what Drace is talking about in Livestream voice text. The
Okay,
shadow would not cast that way.
I got a little. Can I put my camera on? Is that cool?
Hold on, Neil. I want to say this real quick too. You can say that about the hand, but this so-called shadow that comes up the moon and then as the Earth is passing between the sun and the moon, it's a perfect circle on the moon. It doesn't create a sinusoidal at any point as it climbs up or climbs down the moon, I should say. Right? Like
Yeah,
your entire argument is completely fallacious.
Shadow.
Yeah, we got the coup de grace with the Selenilian. We haven't actually gone into that yet. We're just establishing that he understands how shadows work.
Yeah, I don't really. I know how shadows work, so I don't really know what point you guys are making because my statement is the warping is based upon your perspective of where the view is, like not where the shadow is.
Yes, it is based off where the shadow is. No, that's wrong, Sheepdog. It is based. It's based off of how the shadow's projected, the angle of the projection.
It is going to look flat.
It's based on the angle of projection to the surface.
But if he takes his friend, if he stands and looks dead onto the ball, and then his friend puts his hand in front of the light and the hand climbs up the ball, he's going to see a distortion as it's climbing up the ball. I agree with what you're saying. If you're looking at, if the shadow just appears and then disappears in that particular moment, yeah, I agree with that. But you're claiming that the shadow that climbs up the ball of the moon is not getting or wouldn't get distorted at any point when that's totally false.
Oh, I get what you're saying. Yeah. No, I understand. So you're describing like the crescent phase, and then like the half moon, and then like
No.
that's why exactly what you're describing is why those phases of the moon happen.
No, that's not the reason for those shadows. That's supposed to be those shadows occur because that's the side not facing towards the sun. It has nothing to do with the Earth. Don't tell me I'm preaching the globe better than you are. If the Earth, so the Earth is rotating, right? And as the Earth is rotating, and it's going around the sun, at a certain time of every month, the moon and the Earth passes between the moon and the sun based off of the motions that the Earth is supposed to be going through, right? It's going to cast a shadow on the moon at the beginning of the lunar eclipse, right?
Yep.
Right. So as the lunar eclipse begins, the shadow is going to climb from the edge of the moon all the way across the moon. And then it's going to, once it gets to a certain point, it's going to turn the whole moon orange or red, right? Right?
Yeah.
So as that shadow climbs across the moon, at any point, does the shadow ever get distorted?
You know, honestly, I don't know offhand because I haven't looked at the phases of a lunar eclipse in a while.
Okay. Well, I mean, it's something maybe you should look into. All right. And that's just a part of it. I'm sure Drace has more to talk about on that. But your claim of like, oh, if I put my hand up against, and shine a light behind it and I look at it from a certain angle, it's not going to be distorted. You're absolutely right if it maintains that specific angle all the time. But what you're seeing is the shadow climb the moon, climb across the moon. And you don't see any distortion.
You can think of it this way: the either end of the terminator line is always going to be angled away from the observer if it's hitting a sphere. Do you understand that?
Distorted, but it's not looking distorted, right?
Say that again. Sorry, we kind of broke up.
So what you're saying is, as it's climbing it, it should look. Yeah. You're saying as it's climbing it, it should look distorted if it's on a globe, a spherical moon, but it's not looking distorted, is what you're saying. I got to look back into that, but that's what you're saying, right?
Yeah, we're not seeing the distortion based off a shadow being projected onto a spherical object. The claim is that that's Earth's shadow being cast onto the moon during the eclipse. However, there also exists Selenelian eclipses where you can observe the eclipse while the sun is still above the horizon, and what is claimed to be the shadow of the Earth appears to come onto the moon from above as the moon is setting.
I'm actually curious, and I'm not trying to like debunk anything because I've talked to different people that believe in flat Earth, and they have kind of different opinions of it. What is your stance on what the lunar eclipse is then?
We don't know. It's a phase of the moon.
We don't know. We don't make claims. We don't make claims about what we cannot know or test or verify. There are multiple options. There could be some kind of distortion causing refraction between us and the moon. The ancients used to document something along those lines and called it Rahu and Ketu, which would eat the moon and the sun. I don't believe in any mythical nonsense. I just if I can find the data for it, I'll accept the data and how we acquired that data, but I don't need to accept the imaginations about what that data could mean. I just need to look at the raw data, if you understand.
So kind of like a classic skeptic approach, not skeptic in the modern sense, but like the ancient skeptics, right? Like the ones that they're like, I don't know what I don't know, and I cannot be 100% sure about anything. So I'll look at things, but I could always be wrong about, like, kind of having a constant skeptic.
There is the things that can be there is the things that can be known and we do know, but
like the
there is a
philosophical
limitation.
skeptic sense, not like you're just a skeptical person.
There's an element of skepticism, but there is also like things you can verify using the scientific method. There are, like I said, data that you can gather from the real world to establish truths and knowledge.
Do you think it's possible to find out what that shadow is that's going on the moon? Like, do you think there's an experiment that could be done to figure that out?
We don't know.
No, if I knew, I would try to accomplish it or tell people how. Like I can't imagine one right now without, like, I don't have enough money to even be able to test some of the premises required to even try to test it. So it's like really difficult.
Try to have a theory about it, right?
Sorry, what?
I mean, there's nothing wrong with hypothesizing and speculating. Like, you can do that all day long, but then you're going to have to get down to the brass and devise an experiment.
Yeah, the best I can give you is something like you can watch a fly standing on water casting a circular shadow on the bottom of the pool, and that's just due to the indentation from its leg on the water. And so that creates this refractive window, which casts a shadow, even though like there's actually nothing circular there. Casting a shadow is just the indentation in the medium, leading to light behaving like that. So there could be other factors that I don't know about. I don't know what's between me and the moon. I can't test that. What I can test is the ground, are the assumptions that we make when we're trying to make the world into a ball, because everybody knows it's a ball.
So I guess what I'm asking is, there were people that said exactly what you're saying, and then they tried to devise experiments to prove assumptions, and then they did those experiments, and that assumption had, or the result had possible interpretations, and then they're like, cool, we have to test out all these possible interpretations in order to figure out which one's the reason why it happened. And then they did more experiments on that. And I guess the thing that I feel is like, well, they did all that thinking. Like they did this experiment that had these possible assumptions, then they did a different experiment that had a different assumption, and then people did that for about 2,000 years and came to this conclusion. But it
that's not how that happened.
You could do the experiment, it doesn't work.
No, Bro, I studied the history of this. That's not how that happened. What actually happened was, like I told you earlier with the shadows, they made a bunch of assumptions. They saw boats with their naked eyes appear to disappear bottom up on the horizon, and they believed that they had invisible laser beam vision, and they didn't understand how light worked. So they thought seeing the bottom of the boat disappear, or appear to disappear on some days, that meant that the Earth was a ball. And so when they saw the shadow on the moon, that meant that they confirmed their first assumption. But if you understand logic, these are affirming the consequent logical fallacies. This is circular reasoning. If the Earth is a ball, boats would disappear bottom up. I see boats disappearing bottom up, therefore the Earth is a ball. This is not a scientific experiment. This is not proof of anything. And worst of all, we continue on. You mentioned the sticks and the shadows, Aristophanes. Yeah. Did you know that the Chinese also use sticks and shadows, but different assumptions? And their conclusion was the Earth was flat. That's because baked into the sticks and shadows assumption is if the Earth is flat, then the shadows would behave like this, the shadows behave like this, therefore the Earth is flat. Or the inverse, if the Earth is a sphere, shadows would behave like this, shadows behave like this, therefore the Earth is a sphere. The only thing you need to change is the variables in between that are not mentioned here, which are how the light is acting.
Hey, Drace, Neil, I want to do an experiment with your friend on the phone.
About 10 minutes ago.
Hey, I've got an experiment for you, man. Do you want to calculate the circumference of your living room? Assuming your living room is a sphere?
Sure.
Yeah, if you assume, yeah, so you find a light bulb in the middle of your living room.
Are you asking me rhetorical?
I'll give you the instructions. It's literally 4 steps. That's all you need to calculate the circumference of your living room.
Okay.
So the first thing you're going to do is you're going to get a light bulb, a single light bulb. That's all you need is one light bulb on the ceiling, right? And then you're going to take a stick object or a soda can or a bottle. It doesn't matter, right? And you're going to put it directly underneath that singular light bulb. And then you're going to take another object and you're going to measure it however many distance away that you want it to be, 3 feet, 4 feet, 5 feet, right? And you're going to place a similar object, same height and everything, off to the side. And you're going to measure the angular difference between those two things. Whatever the angular difference is between those two things.
You're high school. This is basic geometry. I understand what you're talking about.
Right. So then from there, you're going to take.
You know where the light source. That's why that works. You know where the light source is, so you can measure the distance, the light source to that first.
No, you're assuming that light source is an infinite distance away, and you're assuming all light rays are parallel. And you have to assume the Earth is a ball.
Distance away. The Aristophanes experiment.
He assumed it was an infinite distance away.
Options, like you guys said, and so you cannot assume one of those things is true. You have to test for all of those things, right?
Where did they test that?
For those things?
Whether there is a local light source or a very distant light source. And
how did he test for that?
In order to prove all of those possible results. That's why I was saying, like, I don't believe, and you guys agree. There's no one.
No, we're asking you where did they test the assumptions of an infinite light source with parallel light?
It's infinite distance, or the light is infinite. Sorry, I don't know what you mean by infinite light source.
The light is calculated to be effectively an infinite distance away. So it doesn't matter if it's 3 million miles or if it's 93 million miles. It's the same, and then all the light is parallel. Those two assumptions are required, and then the Earth becomes a ball.
Right, or on a different model, the light source is like 30 miles away.
No.
And
no.
That is flat, right? Like that's the other model.
No, that's you creating some retarded flat Earth model and trying to ascribe it to us. That's a straw man fallacy.
No. Sorry.
Yes.
I'm not straw manning. I'm asking like okay, dude, hold on.
You didn't ask.
There is not only one possible answer from the Aristophanes experiment, right? We both agree that there are multiple possible explanations for why shadows are cast that way. It either is a local light source or it's a very far away light source. Those are two possible answers. Yeah?
The localness of the light source is dependent on the medium between you and it, which is unknown.
Yeah, no, I understand. So that's why I'm saying you then have to do experiments to find the distance of the light source.
Impossible.
Yeah, what's the medium 100,000 feet up? What's the medium 100,000 feet up? What's the medium 500,000 feet up?
Hold on, time out, guys. He's got to shut this down. We had a warning. We can't say the R word, unfortunately. I know it's TikTok, so let's just give our last 30 seconds.
What R word?
Yeah. And I'm going to shut down again in 10 minutes anyway, because I'm just shut it down.
No problem.
I'm enjoying the conversation. Once we got past the craziness, I think we're doing good here, and I'd love to keep doing this another time if you guys can. But
100%.
all I was trying to
I
establish
prefer that you come in here.
is that there's more than one possible explanation for Aristophanes' experiment, right? You're saying it's an unknown distance of where the light source is, so therefore we need to do an experiment.
It's not an experiment. It's a logical fallacy. It doesn't establish anything. That's what we're telling you.
I understand. I understand. That's why I'm saying you then have to do a different experiment to either confirm one of the possible results, or you have to just do a different experiment altogether. Like the two towers experiment, right? Like that one would have to prove whether there's curvature at all or not, or you use a gyroscope, and that one would have to prove whether there's rotation, which is a totally different thing anyway. But so like the two towers experiment, right? That would prove or not whether there is curvature to the land that you're on, right?
What two towers experiment are you talking about?
Like that basic one where it's like you have a camera or a laser on one 6-foot tall stick, and then you go like a mile away, and you have another camera or you have a sensor or whatever on another 6-foot tall stick, and you make sure that they're both at the same exact altitude. And if the Earth was flat, they should just touch each other. Like the laser going straight level should touch the tip of the other one. If the Earth is curved, then you should have to lift up the other stick higher, about 8 inches or something like that, in order for it to have touched that sensor. They did it on that Netflix documentary, and it's a pretty common experiment.
No, they didn't actually.
They didn't do lasers.
They didn't use lasers. They used a flashlight which diffracts going through holes and would have never worked. We, however, have used lasers hundreds of times.
Yeah, so I'm saying like that is a kind of experiment.
So again, you have non-experiments. Again, you have non-experiments and a mockumentary, which is making fun of you. Meanwhile, we have tests using wavelengths of different wavelengths, lasers, infrared.
Flashlight, not a laser.
You have a flashlight.
No, I'm not saying.
Yeah, he broke the laser. He broke the laser when he was going out there to do the laser thing. He broke the laser. He left it on too long, and it broke.
With a laser? Is that what you're saying?
Yeah, sure.
Oh, so like, hey, if you're at a laser, like over a lake, so like you're at a lake, right?
Well, with a lake, you got to also take into consideration the density of the air, the temperature of the air, and the warping of light that happens with that.
Yeah, so I'm just saying like that would be like where would we do this? Because that's the flattest like distance, like, you know what I'm saying? I mean, we can do it in the air if you want. But...
So what I'm saying is like, and look, I'm not trying to get in the technicalities of that specific experiment. My point is, you guys have Aristophanes' experiment.
We do. That's why we're flat earthers.
Yeah, you don't want to get into the technicalities because you don't know the technicalities. We know the technicalities, and we know they didn't use lasers. We have experiments using lasers, although these are not actually experiments. You don't know actually what an experiment is. You're kind of conflating a test with an experiment or a measurement with an experiment.
Right? That's what the experiment should show, right?
I think we've reached an impasse here. It's a lot of talking.
The impasse is because I'm trying to just have like a conversation about.
Yeah, I know.
Come into here. Discord.gg/flat earth, man. Come in here and come say hi.
Yo, we're on his channel. Yeah, no, I got it. But yeah, no, it was nice, dude. Yeah, 100%. Well, I'll definitely be back, dude. 30-second closing statements. Cool.
You guys go for it.
All right, Drace, Sheepdog.
No problem.
You can't prove the shape of the Earth looking at the sky. And Jaren did not use a laser. He used a flashlight by shining it through a hole in a piece of styrofoam. And based off of that observation, he should have been 23 feet tall. And yeah, I just think you have a lot of wrong information, and the devil's in the details. And if you want to actually talk about the details, come to discord.gg/flat earth. What you got, Grace?
Awesome. Thanks, Sheepdog. Thanks, dude. I'll give you your last 30 seconds. Really appreciate it, brother.
What I've been finding is that it's very easy to look at a single instance of an experiment and disprove that and think that the whole system falls apart. When experiments are able to be performed by everyday people in many different ways and get consistently similar, if not the exact same results, it's hard to doubt their validity. So without getting caught up in the specifics and the semantics and actually looking at the broader picture, the picture gets drawn pretty clearly. And I am more interested in why you reject that broader picture and you focus on those instances that confirm what it is you want to hear.
No, we focused on your so-called claimed evidence, and we showed the inherent errors within all that
All right,
so-called
thank you, brother.
evidence.
I really appreciate it. We'll talk to you later. Cheers.
Okay, I don't get to do a finishing statement. Okay, no problem. But I'll finish it anyway. We went over his so-called evidence, which is repeated. Sure, you can repeat an error ad infinitum. It still remains an error.
Who was that guy?
TikTok Glober saying flat earthers don't have a flat earth. We started with like 3 people. We had 40 people in the chat. Let's go.
Yeah, I find it's really interesting. Don't focus on any of the tests or what he refers to as experiments, because each one of them you'll find something wrong with, but focus on the bigger picture. Focus on the bigger picture, the bigger story that we weave with tests we can't really back up.
It's like saying, I know I'm lying, guys, but look at how many people believe the lie. So you should believe it too.
Yeah, he was like teetering on like dogma and evidence and like couldn't pick a side. He's like, should I go to evidence? And then as soon as he went to the evidence, he like hopscotched over to some like, pseudo speech, like, bullshit. And we're like, no, go back to the evidence. It's like, okay, let's go to the evidence. And then he'd run away again. I was like, bro, that was like the entire hour.
Don't listen to the little lies. Listen to the truth, which is the story that we make up about all those little lies.
Oh yeah, and by the way, just an FYI, guys, when we are on TikTok, unfortunately they have some really like strict guidelines. So like, you can't say retard. I don't think you definitely can't say the N-word. What else can't you say? I think just that. But yeah, we just gotta watch out a little bit because I did get a strike, and then he got a strike also. But I don't think he cares. Anyways, continue.
That's why he needs to come in here, man. If he wants to know, have a real conversation, not a what is it called?
Well, how is it going to
moderator.
change him? But how is it going to change? He's just going to get angry and leave if we mute him, right? He's going to be, I don't want to be here. Like, I literally you have to give them like the allowance of being stupid, unfortunately, as a moderator. Even though like you have to make them have like a voice, unfortunately. And if their audience wants to hear a voice of a retard and donate to them, that's their cause. But that's just making us look better, So it's a kind of a double-edged sword, right?
Yeah, to some degree, because it's kind of like you can use the opposition that every point they make you can use to expose more of what you have to say. So every question that they ask helps us deliver the message. So it is a good thing to a point. But then once you get to 8 years with somebody like Just Path of Light, you know, he needs to stop coming around here and go hang out on TikTok.
Yeah, like, dude, if people came into our rooms, right, that would be completely different, right? Then we would be like, all right, mute, you know, we're advancing like the topic, stop filibustering, you know, like shut up. Like, I could have done that 100 times during this conversation, but as a moderator, I'm not allowed to, right? You know, I do it a couple times, right? When he's really filibustering, I'm like, all right, let's like, you know, but I hope you guys would do that for me, and then, you know, I would have to call moderator and then, you know, interject and be like, yo, like, come on, man, get back to the point, like, you know, what's the point? And
Yeah, no, and it's and I mean the truth. Has this guy really even actually spoke with any of us before? Because if this is
no,
his
it's
first
just
time,
TikTok. It's just TikTok Flat Earthers. But he, like
yeah.
I say, he
So I
wants to
mean,
speak
like,
again,
well,
and
yeah.
like I said, I got to give respect when I go to their channels. I have to give like the respect of like, you know, their channel, their audience, and I gotta, you know, unfortunately. So if it gets too bad, we just back out, right?
Oh,
But I
there's
mean, like,
nothing wrong with that. No, there's nothing. You have to start where they are and slowly walk them to where we are. We can't just go in and turn an aircraft carrier 180 degrees in 100 yards.
yeah,
You know, it
because I'm
takes
trying to get
time to
more.
turn it.
I'm trying to get more shows. You know, even like, you know, returning guests, and you know, I mean, hopefully it's not all retards every time. But I mean, he wasn't that bad. Well, I mean, he was, but
Well, but
nevertheless.
if this is his first time being around reasonable flat earthers, then you know, we shouldn't call him a retard. That's his first time here, so
No, but like
it
they cordial. Like he was like a little bit like, you know what I'm saying? He
I
wasn't like foaming at the mouth, right? You know what I'm saying? I know he had like just like as long
thought
as
he
the
was
like
great.
the messages get conveyed both ways. I think that's like the goal. So yeah.
Drace did an awesome job. Sheepdog, you guys did a hell of a job. You know, it's and if he comes back, that's the real victory. Is if we see him in directly in the Discord.dg/flat Earth. If we see him there, then that's the true victory. So hopefully he'll come around and maybe he'll ask some more questions. And if he doesn't come around to our point of view in the near future, hopefully he'll
He'll be
listen to
around
more of
though.
what we have to say. And
Yeah,
yeah,
he'll be around the chats.
because Drace will set him straight, and so will Sheepdog.
Yeah, you guys killed it.
Well, I can just tell by, thank you for the kind words, but I can tell that, like, sitting on TikTok all day, he deals with some of the, like, a lot of the low hanging fruit. And it's unfortunate because he just comes in with the wrong attitude. He's just got this complete straw man because these people have these other people, these other flat earthers, they have these high beliefs already in their mind because they're already trying to explain things that were removed when they lost the globe. And so he just comes in and he strawmans every step of the way. And Drace, I think you did a fantastic job trying to explain logic. I just don't think he was understanding that.
You're just trying to wrangle him the whole time, pretty much. It's like a turtle race.
Yeah, and I really liked how Drace there told him to relax a few times. And, you know, like the guy was, he didn't like that at first, but then I think he realized that Drace was being sincere and not a asshole, like probably some of the basement dweller esoteric flat earthers that he probably runs across regularly. He, so having said that, I figure he's probably a, you know, that had to be quite a shock for him. And I like Drace's tone there, that I thought it was, you know, calling him to be contemplative a moment, and then he stopped. And that brought about a good little pause, and then you all picked it back up. I thought that was stupendous.
How's it going, guys? I'm a Glober. I'd like to get in on this action a little bit.
Welcome back, Dylan.
Hey, just one quick second, friend. Hey, guys, I'm going to back out of here. Have a good night, and welcome aboard, Dylan. I hope you have a good evening. Thanks for coming by, Dylan. Sorry I can't stick around, but have pull up a seat and enjoy yourself.
Peace, Barrington.
Thanks for the warm welcome. Have a great night.
Be
Appreciate
safe, man. So, hey, Dylan, why do you prefer the globe?
It's a lot of
What are you?
things.
What are you? The last guy? What are you gonna ask you to ask him about? You're the TikToker now.
I know, right? How do you prefer the title?
What do Globers eat for breakfast? No,
Yeah.
It's the whole thing. Like the preponderance of so many different phenomena that seem to have an explanation in the one model. Like the way you guys say you're not sure what the celestial objects are. You know, you're not sure what gravity is. Kind of like we have a.
Well, why would we be?
We have this great
Right.
mathematical model. Like, the inverse square law leads to like elliptical orbits, and it's just everything, And I'm not saying that I think there's a lot of lies out there. I should say that it's like
No,
some
bro,
common ground. There
bro,
are some lies.
bro. The understanding of not knowing what gravity is the highest echelon of academia, of the globe religion.
Exactly.
I think they're missing a mechanism. That's the stuff I like.
Misconception.
We don't deny any of the data. We don't deny any of the things that are verifiable in reality. None of that's denied. What we take question with is the things that are not verifiable in reality. And we were like you. We took it all on faith. We took it on faith because smart people supposedly figured this out. And then when we measured the surface and found no curvature, where we expected to find curvature, we started to look deeper. Like, what are we basing this on? We're basing this on very little data. We're basing this on, it has to be something like this because the Earth is a ball and we don't have a lot of data, but this would match with this other idea, which doesn't have any actual evidence, but they keep on stacking these assumptions, just like you just said, inverse square law. Like, that doesn't work for clusters. That doesn't work for galaxies. That's why they need Einstein. That's why they need, and for the rotation of the galaxies, they need dark matter and dark energy. And we don't have any verifiable evidence of that. We just have billions of dollars and all of our most brilliant people wasting those resources for decades and not getting any results.
I think those are fascinating topics. I have some explanations for those, but that's a little bit that may be out of the scope for this. I don't know if you guys are willing to go down those.
Yeah. Every time their math doesn't work, they create another math equation.
There are holes in the standard model, in a sense. Even beyond special relativity, like you say, dark matter. We don't have a good explanation of that, and there's even like cognitive dissonance in the way that we explain things like light, calling it a wave and a particle. This dual nature of light, like that, it cannot be a particle and a wave.
Yeah, and just like the quantum cannot be reconciled with general relativity, and that's one of the reasons why they say, like, we don't know what gravity is because we cannot reconcile all these things. So we're looking for quantum gravity, modified Newtonian gravity. They have like 40 different like primary theories, but there are like 80 different theories overall.
Right. That's actually one of the areas I like to explore. I think that and I have some good theories along those lines.
Yeah, but
one of the things that is why is, but you can't even get into those things because you're kind of throwing out the whole, like, all of astrophysics, in a sense. Like, those are all lies and built on assumptions, and like none of that. There's no alternative flat Earth physics that is comparable.
Well, the physics is generally the same. The only difference is you cut away the assumptions of how you think these things work. It's just we go on first principles. What do we know, so that we can build on that and not just go off into wonderland of imaginations about there's raining diamonds on this planet and whatnot and whatnot. That's just a fancy story
Right.
until we can go there and verify it.
You can see. Well, I heard earlier somebody. You guys agree that there's ISS exists? Do you think the International Space Station exists? Somebody used it as you can't see curvature from the ISS. Do you think it exists?
Well, I think there's something in the sky we can track, and we call that ISS from the ground. And then what you might not know is NASA has a mock ISS inside a 747. They have one inside a pool, and they have one inside a studio. And so what we see from the inside could be whatever. I don't know. I see them using augmented virtual reality, using objects that are not really there, and they can only see on those laptops which are plastered everywhere, so they can see the objects to interact with them, because they only exist on that layer that is broadcast out to the public. But sometimes that layer breaks down, and they're fondling with empty air, pretending to move hats that don't exist.
There are some shady shenanigans, I think, going on in NASA. I lean to the side that there was some fakery involved with the Apollo missions, for example. But in my estimation, it's the whole thing is to hide more of a secret space program. I think, like, you've heard of these UAPs that have been observed, and they don't exhibit the characteristics of normal aerodynamics and like jets and the typical technology that we use for aerospace. So there must be some other mechanism. No,
That does
that's what
not mean
I'm
that.
saying. I'm saying that I think there are some secrets being kept, and to me personally, I think that's one of the reasons Flat Earth has gotten originally started is to try and muddy the waters around the secret space program.
Well, think about it this way. Think about it this way. Where are the first records of these things? They are ancient records, and they're like records of them being gods and Vinmanas in the Vedic scriptures. But they didn't say anything about them living on other planets. All of those ancient cosmologies, which had those
Vedas,
ancient flying things, all of them had a flat Earth cosmology. Vedas had a flat Earth cosmology. China,
no,
all
the
of them.
Vedas
Yes,
talk about many planets.
Yes, they did. What
and
you're
there's
what you're
beings on these
confusing
other
is
planets.
no. What you're confusing is they have a full cosmology with a flat Earth. However, they have a cosmic egg around all of that. That's the only mention of a sphere in their cosmology.
It specifically talks about like Goloka Vrindavan is Krishna's planet, and the cows give milk endlessly and things like that. There's planets for
Those are later translations after the globe became predominant and took over the world as a one-world religion. All the ancient religions had a flat Earth cosmology.
Getting into the ancient civilizations and their understanding of the cosmos is sort of an interesting. Like the Mayans had a pretty rich cosmology.
Yeah, flat Earth cosmology, yes.
Let me add something real quick, if you don't mind, Dylan.
It's Egypt as well.
Don't you think if the aliens had come down here, right, and the humans thought that they were gods, right, don't you think the aliens would teach them that they're in a heliocentric system, in a universe?
It's besides the point. What I'm establishing here is, if you look into the ancient past, all of the cosmologies were flat Earth based, because that is objective reality, how you experience reality. it wasn't until Pythagoras, or that's the claim, that Pythagoras came with this.
The Mayans had a cosmology that included like the spherical Earth and other planets, and
No,
they even recognized the center of the galaxy in the Sagittarius A.
no, those are interpretations.
The Sumerian tablets have been translated really well, and they had a heliocentric model too.
Nope.
Well, maybe these are reference points that may not be useful. One of the thoughts I had recently is about for me, I go back to like the celestial sphere. When you are in Africa, in the south of Africa, let's say, or in the south of South America, and you're looking south, if it were a flat Earth, you'd be looking in different directions. But on a globe Earth, you can look and see the Southern Cross, for example, the southern stars. So why is it that people looking, on a flat Earth, looking in different directions, how can they be seeing the same stars? That's one observable that that I think would have to be explained from the flat Earth side.
They don't, because the sun's lighting up a part of that world, a part of the world at any given time, so they're not all looking at the same stars together.
The sun doesn't illuminate the stars. The stars are there, right?
If you look at Africa, Australia, and South America, at any given time, two of those places are lit up with daylight.
Right, but just like Polaris, the southern axis of the stars doesn't move, right? Like Polaris doesn't move, and neither does the southern.
So you agree that they're not all looking at the same stars?
No, I think if you look south and you're in the southern hemisphere, you're gonna see the southern stars.
Right. If you have one person in South America, if you have one person in South America, one person in South Africa, and one person in Australia, you had them all look south, two of those people will either be in daylight or nighttime. All three of them cannot look at the same stars at the same time. You can Google it. You don't have to believe it.
We can observe that the southern stars are not moving, so you could wait, until nighttime, like, through the course of a day, all of those people can observe the southern set of stars without moving.
Well, you're making an assumption now.
No, I'm just describing the observations as we know them. Like if you're at nighttime in any of those places, you're gonna see the same stars.
They are moving. They are moving. They're moving.
Does Polaris move?
Oh, they say it does a little tiny bit, but I mean, the southern stars are moving in a similar manner to what is observed in the north, as in an apparent celestial rotation point.
How is that possible on a flat Earth?
I don't know. Why wouldn't it be? Why can't the stars do whatever they want? Why couldn't they, be doing squiggly lines and zigzags and all sorts of weird stuff? Why?
Do you agree that if you measure the surface of the Earth to be flat, then whatever is happening in the sky only happens over a flat Earth?
I think that there's something erroneous with the idea that we've never been able to measure the curve. That seems erroneous, but I try not to go down that because it's just already been beat to death. It seems like, not that I've watched all the things, but from what I've seen, it seems like there's plenty of these debates going on. You guys have it like 24/7, right? So, to me, something that we can all see is the sky. We can see the sun. These are observations that you don't require sensitive equipment to observe.
You
We
want to know
know that there's
something
times
weird?
where. Go ahead.
They say that the stars have like a wobble to them based off of the wobble of the Earth. But the planets, when they move through the sky, they don't follow the same wobble. They actually follow a linear path, as linear as it could be. They don't move with the stars. They move in their own fixed patterns. Since you want to look at the
Yeah,
sky,
yeah. The planets do move relatively slowly. We observe retrograde with some of the planets because.
no, you didn't hear me. The Earth is supposed to be wobbling on its axis, right?
Uh-huh.
Right. So if the Earth is wobbling on its axis, which is, they say it's wobbling because of the way the stars move through the sky, right? The only problem is the planets seem to move with that wobble, right? So it doesn't look like it doesn't look like we're wobbling according to the planet. The planets move
I
in a
think
different fixed pattern.
I think that's a mistake. The planet, the way we observe the planets is very predictable in the standard model.
No, it's not. They've missed the transit of Venus a couple of times, and they've missed
They
some eclipses
missed the
too.
So how do you explain the transit of Venus? So Venus is something that's super close. Then, if the sun is super close, then Venus must be closer than the sun.
It seems to move with the sun. It seems to be following a pattern close to the sun. Typical times that we see it when it's on its outer path, furthest from the sun. After the sun goes down, we'll see it in what's called the girdle, the belt of Venus, the girdle of Venus, in the sky. It's this little pink area in the sky.
The most of the planets move through what they call the plane of the ecliptic, and so they're following.
Yeah, that doesn't wobble. That should wobble.
So that's confirmation. So yeah, I still think that the Earth is a globe.
Well, Dylan, another thing, the reason you're kind of like pointing to the sky and going, it must be a globe is, well, that's how we were all taught it was a globe, right? They didn't point to the ground. They pointed to the sky and said, see, this is how you know you're spinning. See, this is how you know you're in space. And they gave us all a story about that. But you're also equating now, like, okay, well, if the Earth measures flat, then what does the sky do? Because that's what I was taught.
It's what I observe.
I observe the
Like
same thing.
the
We all
sun,
do.
for example, is
The same sky, anyway.
if we're close to the Earth and moving overhead the way that it would have to be on a flat Earth, then you would expect the sun to shrink into the distance. We're trying
So
to
what
cover
happens
this
when it
the other
does?
night. Huh?
Does that mean the Earth is flat when it does?
Yeah, it's the
No, not necessarily. And that's what we're trying to tell you.
go
We don't
ahead.
use the
Say
sky
again.
to prove
What did you
the
just
Earth.
say?
I said no, it wouldn't. That would be
No,
affirming
what
the
wouldn't?
consequent. No, just because you saw the sun shrink in size.
The sun doesn't shrink in size. That's my point.
No, sometimes it does. That's why I'm trying to tell you. So what does that mean when it does?
When has the sun shrunk?
I can show you
I
right
would
now.
like to see
In
that.
side chat. Yeah.
And
There's
Dylan,
plenty
just
of
so you know,
examples.
you're absolutely right to ask questions. Once you find out that the Earth is flat, yes, all the stories are wrong about the sky. Whatever's going on in the sky is something completely different. What it is, we don't know. Go
That's
ahead,
why we
brother.
don't use the sky to prove the Earth is flat. Because we know that they're non-analogous.
to me, it makes perfect sense to use the sky to determine factors about
Yeah,
the Earth,
because
just
you
like
were
you would.
taught the globe that way. I was too.
No, I mean, if you're in a car, you look out the window and you can tell how fast you're moving. You know,
You
you
can?
know what
Really?
direction you're going, and
Or do
you
you have
have
to
to
look
look
at the
out the window to know
speedometer?
where you're going. Pardon me?
Or do you have to look at the speedometer? I don't think you can tell how fast you're going at all.
I mean,
Nor would that be analogous. You
you can get
wouldn't
a pretty
look
good idea.
outside to see if you were driving. You'd probably look at the car, wouldn't you?
I mean, you wouldn't be able to tell where you're going without looking out the window is going to give you quite a bit of information about where you're going, how fast you're going, for sure.
If I woke up in a car
Speedometer is
that was going
nice,
in a straight line and I
but that's
couldn't
just
tell that I
as
was
an
moving,
analogy to explain why, like, looking up into
right,
the sky is like our window to, to say like
right.
how the Earth is
Does it
moving.
tell you what color the car is by looking out the window?
I mean, Dylan, I'm telling
It's
you,
an
man.
analogy.
If I looked out the window, right, of a car, I just woke up. I didn't know I was put in the car. I'm now in this car. I don't know I'm in the car, but I'm sitting in this car. It doesn't feel like I'm moving, but everything outside of the car, right, looks like it's moving. Why would you think that the car is moving if you can't tell you're moving?
Why would I think the car is moving if everything outside the window is moving?
Yeah, if you can't tell you're moving, if it doesn't feel like you're moving, you can't. There's no way to tell that it's moving. You have no speedometer. There's no motion in the ground where like you feel like you bounce up and down, or you don't feel the vibration of the road. Right? It feels like you're parked in a car somewhere, but everything around you is moving. Right? You don't know you're moving.
You
Why
wouldn't
would you think
assume
you're
you're
moving?
on. I wouldn't assume I'm on some sort of treadmill and that everything around me is actually moving and I'm stationary. Like the whole ground is flying past me. I would assume
Right.
that I'm moving. If I spin
Why
around
would
in a
you?
circle and I
Right.
see everything turns around me, I don't
But you
assume
know
that
you're
I'm the one that's standing
you
still
know
and
you're
everything
spinning
and
in
the
a
earth is
circle.
actually moving around me.
You know you're
What?
spinning in a circle because you spun yourself in a circle.
Right. So there's going to be some limitation to this analogy, but you understand what I'm saying. Like there's a
I
there's a lot
understand
of
you're trying to
value
make a
once
false
you.
equivalent. I understand that Albert Einstein said that from all observations, it appears that we cannot determine the motion of the Earth from the Earth. And so that's why he developed relativity.
Right. You can't if you were in an elevator and you're accelerating upwards, you wouldn't be able to tell that difference from gravity.
If
That's
you're
like
in it, if
ultimate
you're accelerating in
relative.
anything, you can tell you're accelerating.
No,
You would
I
have
mean
to be
his
moving
point
at a
was
constant.
if you were in outer space and you were accelerating at 9.8 meters per second upwards, then you would feel a downward force of weight that's equivalent to gravity. So you wouldn't be able to tell if that was gravity or accelerating upwards. That they're not that they're basically equivalent. I have an explanation for that though. It's
Yeah,
not in the standard
that's
model.
just the funny thing is, Newton actually has gravity with things falling towards the ground. Uh, so there's an attraction mass between mass. Uh, in Einstein, it's the inverse. The ground meets the object at rest when it's in free fall. So his Earth inflates to meet your feet. But that's just the effect of space-time.
Whose Earth expands to meet your so he's saying that yeah, if the Earth was expanding at
Not if
9.8 meters
this
per
is
second squared,
not if
it was
this is Newton's
accelerating, right?
inertial reference frame, and this is why gravity is not a force in general relativity.
Have you ever heard of the river model of gravity?
Yeah, it's like a river flowing down. Yeah.
Yeah. So that what you experience is a drag force, and then
Yeah.
that would, if there was this luminiferous ether that is the substance of space-time, then that would
Yeah.
provide an
There's
explanation as to why your resistance to acceleration, F equals ma, is like equivalent to W equals mg, because it's just a drag force uh, that you experience when you're accelerating or experiencing, a flow of space around you. So there's explanations for those things. It gets rather complicated as you're trying to tie in special relativity and everything, but it works out pretty
yeah.
well.
Yeah, that's why we have so many different theories, because there's different ways of conceptualizing this, and we don't actually have a test to determine what, because we can't really wiggle gravity yet.
It seems like one of the easiest ways to make a distinction between the flat Earth and the globe model is like distances in the southern hemisphere. It seems like that would be a good way to convince someone
Well,
either way, because
to
like the
me, that's
distance
just
between the
mapping.
southern tip of Africa and the southern tip of South America is one distance in the standard model, and then it's a completely different distance on
Yeah,
the
but
true flat
how
Earth
do you
model.
measure that? Like the Antarctic race took a race around Antarctica, and I saw the video from the race, and they were going full speed on racing yachts with the wind at their backs. Yet, if you calculate the speed, the average speed they were going, based on the time they took and the distance on the globe, they were going at walking speed.
And they circumnavigated Antarctica.
Yeah.
And so you think that they were going around the ice wall? That
No, I
seems
don't
like a much
know.
further
I
distance,
don't
right?
know.
Isn't
I
that a
don't know
much
what they
further
were.
distance, the ice wall perimeter?
No, I don't know what they were doing, how the geometry of the land is laid out, because I don't have enough data to create a world map. I just know that they force us to travel in flight corridors, shipping lanes, and they bend the map using magnetic declination. And so your compass says this way, but you're supposed to go that way. And sometimes that's like uh, your compass is showing you west or whatever, but they want to correct that all the way over to almost like south and beyond. So like you're taking massive turns based on these metrics which are designed just for the globe, but you don't actually measure it in many cases other than relative to the sky, and the sky itself is an unknown. Like we take it
Well, the
for
sky
granted
is
that the
how we
sky itself
determine the.
reflects perfect geometry of the ground, which is how the globe was created. It's they took the the celestial globe and inverted it, and that's what people think they live on. They think they live on this celestial globe, which is just a representation of the sky, and that could be warped. You could invoke Einstein and be like, "Oh, warping time space causes the sky to look like this," and that's why people are going in circles, not realizing that the geometry isn't what they think it is.
I understand what you're saying, but you said you saw ships sail around Antarctica, right? You saw boats sailing around Antarctica.
Yeah, the Antarctic
So
race.
then that's something that they could calculate the distance that they travel based on their speed and
Yeah.
knots, and the distance circumnavigating Antarctica on a globe map is much smaller
the way they calculate how far they go is based, or how fast they go is based on the globe model. So the average speed was walking speed.
Yes, sailing boats often do not go
Racing
fast.
yachts, sorry, with
Racing
some
yachts
of the
go faster
fastest
than walking
winds,
speed usually.
with some of the fastest winds on Earth.
I would expect something like 15 to 20 knots for racing yachts, maybe even faster, but somewhere in that region.
Yeah, based on the model of this yacht, it's been clocked. It was clocked going into harbor at 15 knots.
That seems that's much faster than walking.
Yes. However,
People
that's
walk
the
around
average
like
speed
4 to 5
required
knots.
for the globe model to be true.
But
And they won the race.
You think the speed? So, let's say that if you were taking that average speed for the duration of the race, you could come up with an estimate for the distance that they traveled, right? Time times speed is going to be distance. So the perimeter of the ice wall, of the perimeter of Antarctica on a flat Earth map, is much longer than it is on the globe, right? So that would be a place to settle the debate, it seems like.
Well, no, you would settle the debate obviously on the surface. Like, it's super simple. Like, they claim Earth is curving. That means the water would be conforming to the ball, and we would be able to measure that everywhere. So when we go use lasers or high power optics and we look, we see way too far, and they go like, well, the light is hiding the globe. And so regardless of what you use, you're never going to be able to measure the Earth. But they're not actually accounting for how refraction works. Refraction is not a magic word that you can just use to hand wave away all empirical evidence. Refraction is very specific and light wavelength dependent. So if you have different wavelengths refracting at different rates, and you're claiming that all the light is refracting to give you a perfectly flat view, then we would see effects of that. We would see separation of wavelengths. We see no evidence of that. And so we go
If you're
out and we
using a
test it.
laser, lasers have a single wavelength,
No, I'm
so
not.
it's not going to.
I'm not even into lasers yet. I'm just talking about basic observations at this point. They're claiming we can see
It
10
does seem like
times speed.
refraction is one of those atmospheric effects that it changes based on the atmospheric conditions dramatically. So
the refractive index of air is 1.0003, which is
right,
very,
but
very
if the air
little.
was all the same temperature, the same pressure, you wouldn't get bending of light. You only get bending of light when you have a gradient of
bingo,
temperature and pressure. And
That's
that's going to
correct.
change.
That's correct, and that's why we
Based on
test
the
under
weather.
all conditions, and we test under conditions where the refraction is the least. And so when there's the least amount of refraction, we can see the furthest. So that's the opposite of the globe claim. The globe claims that when you can see beyond the globe geometry, that's when there's the most amount of refraction. So that's the opposite of what we experience. And so that's why I was talking to you about wavelength dependence of light. And so when you look into something at a distance, all the different colors that you see are different wavelengths. And those colors would distort. So white light would separate into different wavelengths based on the refraction. So the more refraction, the more separation. This is literally how the American military uses its targeting systems. Uses tri-lasers,
That's how rainbows
different
form.
wavelengths.
Yeah, we're familiar.
Yeah, 3 lasers, different wavelengths, and you see the separations between the beams, which the computer can then calculate and correct for. Like it's very simple, and then
That's how infrared was discovered, actually.
Yes, it was discovered through splitting of light, and they discovered that the heat outside of the spectrum, there was no light there, so they called it the invisible light. And then infrared because it heated things up, and Herschel proved this. And
Yeah,
that's
the
one of the best
warmest
parts.
thermometer was outside of the beam of light that
Yeah,
he could see. It was pretty fascinating.
it was awesome. But the best part about it is infrared refracts less than visible light, and so we should be able to see then whenever we look in visible light, and we see way beyond the supposed globe geometry, and now light's supposed to be refracting to allow us to see this far. And then if we look at the same instance, same time, we take up our infrared camera and we look at infrared, or do we see less or do we see more? What's the general trend? And the trend is, if you look at all long distance world record photographs, they're all in infrared because infrared cuts better through the haze, and so you can just see further.
I think they use infrared telescopes for that reason too.
Yep.
So yeah. All very
Do you
exhausting.
know
You're
what
saying
rigidity? Do you know what rigidity in space is?
rigidity in space. I mean, that's a material property. I'm not sure what you mean by rigidity in space now.
It's also called the gyroscopic effect.
Right?
Yeah, and so mechanical gyroscopes operate on the gyroscopic effect or rigidity in space. And so if you spin up a gyroscope and you move it across the surface of a sphere, or if you rotated that sphere with it attached to it, that gyroscope would drift. We don't see that drift in mechanical gyroscopes because they're rigid in space.
I'm pretty sure that they've observed the 15 degrees per hour.
Nope, not in the gyroscopic effect, not in mechanical gyroscopes. That would be a broken gyroscope. Foucault, the guy who came up with the pseudoscientific tool of Foucault's pendulum, tried to create a mechanical gyroscope that drifted that much and was laughed out of the room by his contemporaries because it breaks all gyroscopic effects and just makes it unfunctional. So he went on with this Foucault pendulum, and what you're actually referencing is the optical gyroscope and the Sagnac effect, which is a completely different effect, and is the effect of light not being constant, which debunks Einstein. But because that was such an uncomfortable understanding, that Einstein wasn't correct, and so many people believe this, they just redefined the speed of light to be by meter, and meter to be was redefined to be defined by the speed of light. So there is no difference in the equation for the speed of light, and it all works out. It's a constant, like Einstein wanted. However, the Sagnac effect still exists and exhibits drift. However, it only exhibits the drift that we see in the sky, or like we see the stars and the sun move, and that's somehow picked up in the light, in how fast the light moves in different directions. However, it does not pick up any motion of orbit or solar motion or galactic motion or all the other claimed motions. It only picks up the motion of the sky, which people like Witzit are arguing like this is something related to the ether and some kind of ether rotation. But I don't know what's the cause of these things.
You'd have to be at the poles too to get 15 degrees an hour.
Yeah, that never made sense to me too, but that's what this model says, that you get a difference based on being at the pole or at the equator, but you should still see 15 degrees per hour. All the other motion is so much slower than the course of a day that it would take that long periods of time to to measure our orbit around the
uh,
galaxy, for example. It's like
no,
many
no, no,
thousands of years. I think it's like 28,000
yeah,
years or something.
yeah, you're missing the point. Optical gyroscopes can detect linear motion, and
Why would the motion of the stars, if they were moving, like why would the effect of the light be
unknown. That's an
as I
unknown.
understand, this gyroscope is like an enclosed device. Didn't they do the experiment with it in a Faraday cage and everything, like a lead
The
lined
sec,
box, and they were still
yeah,
getting the same?
no, that's that's the funny part is they did try to put, for instance, the optical gyroscope into a vacuum chamber. As soon as you evacuate it, it doesn't drift at 15 degrees per hour anymore.
Totally bizarre. Yeah, I have to look into that. Seems like you guys put a lot of effort into this whole research, but it's so obvious to me as a globe that I don't even know where to go. Because what seems so obvious to me, like I mentioned, the sun does not appear to be shrinking in the sky. You said, oh, there's evidence that it's shrinking, but I can see it. You know, I can see the sun setting every day. I want to see it, and it's always the same size, pretty much. You know,
Yeah, yeah, but
and
that's all.
what I would want to see in order for it to be a flat Earth is for it to be shrink, because it would have to be very close on a flat Earth, right? It would have to
No,
be. You think the sun could be 93 million miles away and still on a
no,
flat Earth?
not 93 million miles away, but it doesn't need to be very close either. There could be different mediums between us lensing it to us.
Well, that's true, and not to mention that it may not be an object as we understand it, and we're thinking of it as.
Yep.
If you just because we see the lensing effect, like it appears to be smaller as it's noon overhead. That's probably
No, no,
the
no,
smallest
no.
point of it.
What,
But when the
what
sun is
you're,
noon overhead to me, it's rising six time zones over, right? It should be right on the horizon.
I understand. However, do you live near the ocean or do you live high up?
I live near the ocean.
Okay, so that's generally more humid. So you have conditions where you live which lead the sun generally to appear to disappear earlier than if you were in a non-humid area or higher up. And so under those conditions, where it's non-humid and you're not very close to sea level, you can see sometimes, depending on the conditions of the air between you and the sun, and with a solar filter, the sun appeared to get smaller. Normally, most of what you see with the sun is a glare outside of the actual emitter, which is a black body radiator that radiates all the spectrum of light.
But you would have to observe the sun to be shrinking to like a dot in the, in order for the Earth to be flat and there to be time
No,
zones, the Earth has to be close to the sun, relatively close. And
no,
because the sun
no,
is acting then like
not
a
really.
spotlight over these different time zones, right?
No, not really.
How can you have a sun be very far away
It could be a medium distance
if it's a
away, and there
flat
could be
Earth and you have
lensing of.
time zones?
It could be a medium distance away, and it could be lensing effects. And what we actually see is the sun does sometimes appear to go into a small dot and disappear above the horizon. Other times, when you're close to the surface where you live, and if you take a high power zoom camera and you zoom at the sun, you can see that the sun squishes at the horizon, and it doesn't disappear always appear to disappear bottom up. That would be when the light bottom rays of the sun are getting refracted and bending down, and so they're hitting the surface and not reaching your eye, and so it appears to be cut off. Other times, it's bending upwards because of the conditions, and then the sun gets squished into this oblong thing until it disappears above the horizon. like there's multiple observations. Cherry picking observations is not a strong argument.
I've never seen any observation of the sun shrinking to a fine point and disappearing above the horizon. It's always relatively large at sunrise and sunset, and even when it's the only thing that can occlude it is like clouds, that can make that observation more difficult. But in Florida, we have really clear skies a lot of times, and you can see that effect every day, pretty much.
Yeah, and you have humidity, and you're low to the ground, so that you're in a more pressurized area, so there's more optical
But
density.
these are localized effects,
And
so that's what my point is. Even if
yeah, these
we can rule out the fact that the sun is actually shrinking and expanding, right? Can we rule that out? Because me seeing the sun setting, somebody else is seeing the sun at noon and at every angle, depending on your longitude, right?
Well, everybody sees the sun, but and yes, you're right that like it can appear of a certain size to everybody based on its apparent distance to you.
Right. So because somebody's seeing it larger and somebody's seeing it smaller because of these atmospheric conditions, doesn't mean the sun is actually changing size, right? We know that the sun is.
No. That's not what is being said. What is being said is the sun is being tracked from its zenith all the way to the horizon, and using a solar filter, which should take away the glare. And the globe claim is the sun should never change angular size because it's 93 million miles away. However, there's evidence that it does.
From this atmospheric conditions, the
No,
atmosphere.
not from atmospheric conditions. When you are able to see the sun for longer because the light is not being forced to hit the ground, then you can see that happen.
Then you can see the sun shrinking or expanding in size, you're saying?
Appearing to change angular size.
Right. This apparent change in angular size that we're seeing is based on the atmospheric conditions and the local angle that you're seeing the sun. But somebody else in another place is seeing the sun at this other angle, right? At this other angular
Yeah, and then it looks a tiny bit
resolution.
bigger than when for the guy who was looking at it in the right conditions where he could actually see it appear to shrink tiny bit. But let's imagine both of them are using solar filters, and it appears to shrink a tiny bit in the diameter where he is, but then another friend is further away in that direction, so the sun is directly above him at his zenith. He checks its diameter. The diameter is now bigger than what the other guy is measuring, because the sun is apparent. It's in the eye of the observer.
So these are localized conditions, though, right? So we can the angular size of the sun does not appear to be changing based on distance. It appears to be
Oh,
changing
yes, it
based on these
does. Yes, it
atmospheric
does.
conditions.
We just went over that.
We would predict it to be the largest when it's directly overhead, because
yeah, that's what we show. It's the largest when it's directly ahead above you, and then when it's as far away from you as it can get before it's occluded, then
it should shrink to a dot like any other object.
No, it should shrink based on its distance. However, if there's other factors that cause you to not be able to see it shrink into a dot, like it gets pushed down, sinks, because the waves or the light doesn't reach the observer, it's going through denser and denser medium, it gets pushed down, and it hits the ground, and that's the end of that light. But from the perspective of the person standing on the ground where the light hit the ground, they see the sun above the horizon. That's why the sun is apparent. That's why they say the sun isn't actually there at the sunset or sunrise. It's actually beyond the horizon. It's an optical illusion.
It's an optical illusion. You would expect any other object, like looking down a corridor or watching a train, travel into the distance. It shrinks to
Yeah, it's
a point.
perspective. Yeah.
As perspective, yeah, that's what I mean. So according to perspective, we're not observing the shrinking of the sun the way that it would have to be shrinking, moving away.
No,
We're observing this other atmospheric lensing humidity that you're talking about.
No, you are observing slight shrinking as it's moving away. However, there are other factors that come into play, which are there's magnification. So if you have magnification, that can counteract diminification. So if it's shrinking, but that shrinking is less or the same, then it could grow, it could shrink a little bit. So there's variables that can play into that.
It sounds like you're just kind of obfuscating a little bit, because unless I could see some picture of the sun shrinking to a dot at some point, you're saying that
We
that
have
does
them.
happen
We have them
sometimes.
in the live stream voice text. They've been playing here for a long time for the bot.
So did someone put that in there recently? Can I go look at that?
Yeah, it's been there for the whole time.
However, Dylan, I was saying earlier too, you wouldn't use the sun though, or at least I wouldn't use the sun to prove that the Earth was flat. But obviously, in your point is just it's just wrong. Like you're just going to wait for the sun to do something, and it means something else. If it does this one thing, is it now not this?
Seems pretty consistent to me. The way that to me it seems obvious that the sun being of relatively constant angular resolution, angular distance, or whatever you would, what would you call it? Angular, the width of it.
Yeah, the angular diameter. Yeah.
Yeah, angular diameter. Seems constant based on all the observations that we agreed upon, that people are observing the sun going through its
But it's not.
phases across
What are you talking
longitude.
about? Are you hallucinating?
Go to different locations. Go to this live stream. There's like 5 different ones.
That's what I was trying to look at, these pictures that you're talking about.
Oh yeah, it's right above this. It's like the channel right above it, not the little chat bubble that's on the live stream. It says live stream voice text. I mean, just to ask you, Dylan, when you go outside and you look at the sunset, do you feel like you're actually spinning backwards and the sun is still?
I do, yeah. I know most people, even that believe in the globe, like still consider the sun to be setting, like as if the sun is moving, because most people are not thinking about what's really going on. But I also think of the sun as the downward direction. I think of the whole Earth as orbiting around the sun, so that we have sort of a local downward direction because of the Earth, but really down is whatever you're orbiting around. So like you're looking at the sun, that's down, and then for the whole solar system, you'd have to look towards Sagittarius A, because we are spinning around the galaxy. We can see
You don't have down. You just have in and out.
You also don't see that out in space. You are just imagining that. You've never been out there to actually witness these orbits. But like, if you take a look at the one that Drace posted, or like the one right before it, right? Does it look like we're spinning backwards, or does it look like the sky is spinning? And in this case, do you ever look down a hallway and notice that the lights are going down in your perspective? They aren't really going down, though, are they?
Well, to answer your first question, yeah, it does feel like we're spinning on the Earth to me. For sure.
You feel the spin of the Earth?
Pardon me?
You mean like appears to be spinning, or you feel the spin?
You don't feel the spin.
Okay.
Even at the equator, the centripetal acceleration is like less than 1% of your weight. So you're gonna.
Right.
But
So
that's
you
another
don't feel the
experiment that
spin.
you could do. You could take a weight
They already did that.
and measure it at the equator, and then measure it at the poles, and you should see this.
And they already did
change
that. It's
in
called the GNOME
weight.
experiment. And what they did was they shipped this GNOME all over the world, and they intended to prove the Earth is rotating with this, but it just didn't do that. Didn't come with a positive result.
They took a weight and tried to measure the weight at different longitudes, and they got a null result. What result you're saying? They
They
weren't
did
able to
basically.
prove the change
They
in weight?
didn't get the expected centrifugal difference from the Earth rotating, and they chalked it up to it must have just been the mass distribution or gravity within the Earth. So
Right. There's a
oops.
considerable. They can measure seamounts based on the change in gravity at the surface of the Earth. They're able to use slight changes in gravity to measure physical objects underneath the ocean. And yeah, there's like strange asymmetries in the distribution of mass inside the Earth that we're able to measure based on that too, the change in gravity. So maybe that does throw it off. If the mass is not evenly distributed inside the Earth, which would make sense. But I'm gonna look for this peak that you mentioned.
Yeah, I think he took off. But I hope he finds what he's looking for. But the reason I asked that question too, like, does it feel like you're moving backwards and the sun is standing still? Is because it's kind of easy to even bring up in conversation, or even like, something simple. And somebody being honest right next to you, right? And you're looking at the beach. Whether they want to say or just kind of double down too, because they usually do. Like, yeah, it feels like, yeah, if we kind of just imagine for a second, they'll even say that too. I feel like I'm going backwards, but you have to be patient. I had this one teacher actually in my architecture studio where we had to lay on the ground and watch the moon, go by, and she was like, "You feel like, guys, we're on the spaceship Earth." I'm like, oh brother. But yeah, I mean, he immediately goes into the imaginations of orbits, and this is how we know this light is doing this. Which, don't get me wrong, I mean, you can build a model if you want off of observations of the sky. But can you test them? Can you verify them?
Yeah, that's where it dies. You can build a model of the sky, but when you try to transpose that model onto the ground and the ground doesn't actually conform to your model, then your model just dies.
Every time. Always good to hear you guys. I usually mostly listen to the live stream and make sure that it's always running. But got another computer, so it's totally much easier to do the same thing at the same time.
Just muted on my side. Okay, hey, I guess I'll play you guys a song while it's very quiet.
They need compliance, I need a claim. They need silence, I ask by what chain. Orders sound loud when reasons are thin. So they recommend in confidence and grin. If it's coherent, it welcomes a test. If it's irrational, it dodges arrest. You say just trust, I say define. Truth doesn't flinch when you draw the line. You confuse force with being right. Volume with proof, authority with light. If it collapses when question once, that wasn't knowledge, that was a front. I don't obey what won't explain. I don't kneel to a broken chain. If it's real, it survives the view. If it needs obedience, it's not true. Not true, not true, not true. Rational paths don't ask for fear. They stand up clear when you bring them near. I don't rebel, I just refuse claims that live off because we choose. No, 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 no. You call it order, I see control. Rules with no reason take their toll. They need agreement before the facts. I need consistency, that's the pact. If it's sound, it doesn't mind every angle, every line. But if you threaten when I inquire, you've already told me what you fear. Truth doesn't need a shield or guard. It doesn't punish thinking hard. If asking why it's seen as sin, that system's lost before we begin. I don't obey what won't explain. I don't kneel to a broken chain. If it's real, it survives the view. If it needs obedience, it's not true, not true, not true, not true. Rational paths don't ask for fear. They stand up clear when you bring them near. I don't rebel, I just refuse claims that live off because we choose. That's it. No shouting, no throne, no sacred tone. Just follow the structure, leave it alone. If the rule holds, it holds for all. If it needs force, it's bound to fall. Not over time, by definition. Contradiction is the admission. I don't obey what won't explain. I don't trade thought for a chain. What is rational stands on its own. What is irrational needs a throne, needs a throne. You call it order, I call it fear. I call it done when it can't go here. No rage, no fight, no excuse. Just scrutiny, and what survives it is true. This is true. Yeah. Explain it or expect resistance.
No, yeah, I get that part. Like I understand that. But
Right.
what I'm saying, okay, you see where that deviation is happening,
Mm-hmm.
right? I don't believe that you would have, or whoever did the experiment would have
Mm-hmm.
access to the instruments that would
Mm-hmm.
be able to simultaneously show a picture of where the deviation should be happening and it's not happening, and also be have a laser that big. Like we're talking
Well,
about, like I don't know, like thousands of kilometers.
so not thousands of kilometers, like tens of kilometers, right? Like the laser test that I showed you. If you look at if you watch the first documentary, they make an observation 40 kilometers away, 28 miles. All right,
Yeah.
more than enough to determine the curvature of the Earth. They shoot the laser at like 5 feet above the surface of water, and they put a boat out over the water, and it hits the lower part of the hull, which is also 5 feet above the surface of water, at 40 kilometers away. There's
I
no
don't think 40
deviation.
kilometers is enough. I don't think 40 kilometers would be enough.
Well, if you go to the beach, how tall are you?
I'm 5'11" and a half. Normally I just say
How
6 foot.
how far away from your eyes when you go to the beach do you think the horizon is?
I have no idea.
It's about 3 miles, or about 4.8.
Okay.
So after that distance, like you should start dipping behind the curve. There should be deviation.
Yeah, no, so what's the evidence for that? According to like the standard theory.
Yeah, because the Earth is a ball. I'll show you. Here is the geometry of it. Right. There you go.
Yeah, so this is helpful. Okay. Yeah, so your instrument should be at least measuring at like I don't know, 500 miles at a
Why?
minimum.
You you
Because
you
that's
understand that light scatters and dissipates over distance through a medium, right? The
what
air
does that
has a thickness. It's not like air is completely transparent.
okay.
So like when you shoot light through air, eventually it's going to reach a point where it scatters so much that it's no longer perceivable with the eye, right?
Yeah, but don't you feel like yeah, sure, I understand that. Like you're saying it's just not physically possible to take a picture at that distance, right? But
It's not even possible to
but
shoot a
like
laser at that distance.
but
The U.S. Navy
the
used 100 miles.
I'm like I know it's just a picture and it's not going to be like accurate, but if you look at like and I know it's probably not even like a ratio, but like if you look at this picture, like imagine where 40 miles is on the picture, like from starting from zero. That's like it's pretty much still flat. You get what I mean?
Say that again.
So on the picture, when you go from zero
Hmm.
and you go 40 miles out,
Hmm.
like it doesn't surprise me that the laser and the ground are parallel
Why,
because the distance is so short.
bro? 4 miles is where the curve of the Earth is supposed to be, not 40.
Yeah, but look at
This is
the
10 times beyond the curve of the Earth, and there's no curvature.
yeah, but it even says in the chart it's 0.020. That's like a rounding error.
That's 0.0202 miles, 10.67 feet. That's if you're 0 feet above the curve of the Earth, right? So if you put your eyeball down all the way down at the very edge of water and you looked out over water, something that was 4 miles away would be obstructed by 10 feet of curve.
Wait, I'm getting confused.
If you want, here I'll put an Earth curve calculator in here. You can type in Earth curvature calculator and do the research yourself. They literally have Earth curvature calculators in the
So I think
in
the reason
this
I'm getting confused is because
internet.
I'm Canadian, so we use the metric system. I have to like kind of do
It's
the.
kilometers, miles. It doesn't matter, man. Curvature is curvature. Man. Like in order for you, see, like I said before,
This
when you
is
were a child, you were taught that the Earth is so big and you're so small, so you're not going to see the curvature of the Earth. That's what you were taught. The problem is they told you that you can see boats going over the curve.
yeah. So in the chart where it says drop, what does the drop is measuring from sea level?
That's the deviation. The drop is the
Yeah. So
deviation.
it's
So you have
the
to have a starting
deviation.
point and an ending point. If you start somewhere, right, and then you travel 10 miles to the next location, that new location is now your new starting point. So you're going to
Okay.
have to, you'll have to get two people, right? Or get a laser or some kind of, you're going to have to find some way to have somebody staying at the starting point so you can go to the end point and determine your observation. You can't start at the start point by yourself with no devices and then move to the end point and say, oh, it still didn't look curving. That doesn't prove that the Earth isn't curving. Like that's
No,
retarded.
I get that part, but where is the deviation measured from? Like, is it from like
The
where the starting
deviation is
point
from
was?
the tangent, the laser.
Okay. Okay. So, no. So, okay. So yeah, if 10 feet.
So if you shot a laser, right, that's going to be a straight line.
Right.
And then as you get further away from the gun, the laser gun, right,
Yeah.
that laser gun is going to be the starting point. As you move along the laser and you get further and further away, that laser is still going straight, right? As you move
Yeah.
further away, that laser should get higher and higher above your head because you're going behind the curve of the Earth and starting to go around the ball.
Okay. Let's do it this way. So, under your theory, the starting point and 40 miles out is going to be, let's call it variable x, right? So it's going to be x
Mm-hmm.
from the starting point to 40
Mm-hmm.
miles out, right?
Mm-hmm.
Under the
X
standard
is where the
theory,
laser gun is.
yeah, x is the distance between the laser and the ground. And your
Okay.
theory would just be the
X is
same
the
for that,
distance
right?
between the laser and the ground. A is
Yeah,
going to be your laser starting point.
yeah.
All right.
And
X is the height
b,
of the laser. Let's do it this way, okay? Let's do
yeah.
it this way. I'm sure you can draw this out. If that's what it's going to take, I think I can walk you through this. So A is the starting location. All right.
Yeah,
X is the height from the ground or the water, right? From
yeah.
the top, from the surface of the water to the height of the laser, right?
Can we see? That's where like I have a problem. Are you
Okay.
measuring
Why is it?
it? So you're measuring it from the height of the water
Uh-huh.
until the
To the height of the laser where the light hits.
okay.
And we're using water because water is supposed to be curving around the ball,
See, I don't know. Okay, wait. Let's give me a second. Let me think. So, but okay, if you're using water, the
right?
water is always going to be flat because the water is filling
I know the water's
some
flat, man. That's the funny part, right? Because like if gravity's pulling water down on the Earth, right? And water is flat everywhere, right? Like the standard is that you have sea level, and everything is, all elevations are based off of sea level, right? And water's flat everywhere, but 70% of the Earth is made up of water. Then you can't have a ball.
Okay, and you're saying the standard theory is that it's going to be x plus, for example, x plus 1, x plus 2, x plus 3, x plus 4, right? But you don't see that. You just see x throughout.
Right. It's just X. Like it's supposed to
Okay.
be an exponential deviation. Like for every mile, 8 inches squared. So at 10 miles, that's 8 inches. Is it 8 inch or not 8 inches squared? It's the miles squared times 8 inches. So at 10 miles, that's 100. 10 squared is 100 times 800. So 800 inches at 10 miles. That's 800 inches of curvature. That should be measurable, which calculates out to 66.67 feet.
Okay. So you're saying under the standard theory, the surface of the water is going to be curving out as you go further along, right?
Yeah, it'll start to bend downward because the ball, you would be curving around the ball. I'll give you another animation to show you this animation, copyrighted by Rob Skiba. So, we miss you, Rob. You were a warrior, dude. Appreciate you.
Oh, he passed away?
Yeah, he died of COVID.
Oh, sorry to hear that.
Damn, did I get rid of it?
Hey, Sheepdog, you there?
Oh, here we go. I got it. What's up, man?
You remember Lo-Fi Guy?
Yeah.
Bro, he's on TikTok.
Oh, yeah?
Yeah, I just found him. I thought he was just some dumb flat earther. And then all of a sudden I'd go to his page, it says Lo-Fi Guy. I'm like, damn. It makes sense because he talks a little bit slow and but he has like the Bible in the background and stuff. Anyways, I'll let you guys continue. I haven't seen him in years, bro.
Yeah. He's cool, dude. He's like big on the whole lo-fi thing. So if you look in the side chat, Mark, right?
Yeah.
You see this balloon, and the idea is that in both of these images, imagine a balloon sitting in the center of both of those images. As you raise up in altitude, you can see how you see how the white line is still there. That's your what they call a true horizon.
Yeah.
That supports this, and then you have the. This is tough to remember the terminal. Just bear with me. Here we go. So you have the astronomical horizon, which is that white line, and then the true horizon, which is the curve of the. And so that blue and gold thing, that's the curve, that's the Earth as you raise in altitude. And then so what happens is if you notice as you raise in altitude, the Earth should start to dip away, right? Now we agree that the Earth is really, really big, but over distance, if you shot a laser, the laser would stay in line with that white line. And as you go further away from the laser gun, that laser would get higher and higher above your head, just like this image where this hot air balloon is gaining altitude.
Right. Okay.
So that's what we're saying with the laser observations.
Yeah.
You're taking a laser, you're shining it at the astronomical horizon as you level the laser to make sure that it shoots horizontal and parallel with the surface, right, as best as possible.
Yeah.
It should be level, and then over distance, the Earth should dip away.
Okay. So yeah, I get what you're saying, and because you know the objection I had was that the 40 miles is just too short. But according
Hmm.
to that chart, then what would you have? About 1,000 feet, which is yeah, that seems
It's
it
crazy.
seems reasonable enough to actually detect. I guess like the other place I can think of might introduce some error would be because if the Earth is rounding, right? What is the
Mhm.
thing that's considered to be rounding? Is it sea level that's rounding, or is it kind of like the the actual? Because when you the water sits on top of the Earth, so wouldn't it make more sense to measure the Earth rather than water that sits on Earth?
It's only 28% of the planet, quote unquote, right?
Yeah,
72%
but
of the planet, the surface of the planet is water. I
okay.
can pick up dirt and move it into a location repeatedly and make a mountain, right? It's not going to naturally curve on its own. It could be molded in, right?
Right, but isn't it possible for the Earth to uh curve and the water that sits on top of it to remain flat?
No, because if you look at the here, I'll just put this one. If you look at this image, right? What's that blue stuff?
That's the water.
Right. And 72% of it is curving, right?
No, no, I'm not talking about like the whole Earth. I'm just talking about like your experiment. Because
Right.
your
So the
experiment,
water has to be curving, right?
yeah, but your your experiment is that you take a laser, excuse me, you take a laser, you shoot
Hmm.
it, and
Hmm.
then you 40 miles out, the x variable, which is the height between the laser and the water, remains the same throughout. But what I'm saying is that it's possible for the Earth to under the water to curve, but the water that sits on top of it to remain flat.
How so?
Because water just fills whatever container it's in.
Okay. So in the image that I posted in the chat, is the surface of that water flat?
Yeah.
The globe that I posted in the chat, that's flat.
Oh, wait, which one are you talking about? The last image?
The second to the last.
Under your theory, it'd be flat, and under the standard theory, it'd be curved. Yeah.
Well, I mean, so we're testing that theory, right? Like they're telling you by this image that the surface of water is curving around the ball.
Oh, okay. Yeah, sure. Okay, yeah, I get what you're saying. Yeah, but I'm talking about like where your experiment is being done. Let's say, for example, I have a cup, right? I have
Hmm.
a mug with tea in it, right?
Hmm.
And then the bottom of the mug is flat. But
Right,
let's say magically I punch a hole in the bottom of my mug and then I curve the bottom of my mug, right?
right, right,
The surface of the tea on top of the mug is still flat, whether it was curved at the bottom or not.
right.
Yeah.
That's fluid dynamic. That's fluid dynamics. That's the behavior of water on the surface at rest, everywhere,
Yeah. Yeah.
inside of a
So
container.
so couldn't it be possible that the experiment that was being done with the laser, the bottom of the earth was curving, but since you guys are measuring from the water on top, it's going to remain x variable throughout.
No, because what's the outer edge of that sphere that I showed? Not the bottom, not the bottom of the ocean. What's the top of the ocean?
Yeah, but you keep talking about the sphere, but I'm talking about where you're doing the experiment. Sure, the standard theory is on a whole, the whole thing is going to curve. right?
How many feet of curvature did you say that was supposed to happen over 40 miles
Yeah,
or 40 kilometers?
yeah.
28 miles?
1,000 inches or something. Or I don't know. Your metric system is so weird. What is it?
Here, just plug it into this calculator. Here, I'll do it right here.
1,000 feet.
Imperial 5 feet. $28 miles. Convert that over to metric. So that's 1.5 meters at 45 kilometers. You're looking at 125 meter, 129 meters, roughly 130 meters of curvature over 45 kilometers.
Yeah, so it's very reasonable for the Earth to curve 135 meters and the water that sits on top of it to remain flat.
No. What's the outer edge in the image that I showed you? Is that the bottom of the ocean or is it the top of it?
Brother, your experiment wasn't done on the entire globe. You keep talking about the globe, but I'm talking
It
about your
was
experiment.
it was done on the surface of the water, and in that picture that I'm showing you, the surface of the water is curving. That's the one they'd show you to say, "Oh, look, we went to outer space. See, the Earth is a ball."
Yeah, but in the standard theory, they wouldn't say water's curving in all places on the Earth. They wouldn't say that.
Google it. Is water curving around the Earth?
No, yeah, I agree with you. Okay, let me see if I understand you correctly. You're saying that in the standard theory, what was it? What'd you say, 28% of the Earth, or what percent was it?
72% of the Earth, the surface.
So 28% of the world is Earth, right? And then 70.
The
Wait,
surface, yeah.
Yeah. So all of that, you're saying under the standard theory is all of that water is going to be curving, right?
On the surface. It has to be.
On the surface, right?
Yeah, it
And I'm
has to be.
saying what I'm saying is that sure, that's not being disproven by the experiment that you guys are showing. Because the experiment you guys are showing, wait, where was it actually? To be fair, where was it done?
They did it over a couple of lakes in the observation. I can look it up.
Yeah, so I guess it would it would depend on where it's being done, right?
It's just done over water.
Yeah, but if it's done on a lake or something, then obviously.
Well, the lake was
that's
40 kilometers wide. It's like a lake in Europe or something, Africa, somewhere in there, Russia.
Yeah, so it's kind of like my mug example. If it's possible for the earth under it to curve and the water that sits on top of it to remain flat.
So 72% of the surface of the Earth is flat.
So
tell me when you have ever seen a ball where 72% of the surface was flat.
I again, I feel like I'm repeating myself here. I'm not talking about the Earth. It's possible that you could be right about the entire Earth, right? I'm not saying you're wrong about that. What I'm saying is that there could be an alternate explanation for the experiment that you told me. That's what I'm saying.
You want to see what the Earth looks like without water? Supposedly.
Sure.
There you go.
Is that the colored one that you just sent?
Yeah. So if you take the water off the Earth, that's what the surface of the Earth is.
That's strange.
So you can see how the water would make the Earth look more spherical, right?
Right. Yeah. Anyways, man, this is some interesting stuff. I'll check out that playlist.
Please do.
Yeah, but I enjoyed the discussion, and perhaps I'll be back.
Thanks, man.
All right, bye bye.
Come back. Hey, matter of fact, if you actually want a cool place to go and check out some more information, if you look on my tag where it says flat, and there's also a YouTube bot up there at the top of the recording, it says flat. If you click on that, it'll take you to our home server, and from there you'll interact with. There's like 30,000 people in that server. Not everybody is a flat earther, but that's where we have like a library of information at the bottom of the server. Welcome to check it out. Any questions you may have, we've probably answered it several times. So, but come back, man. We always enjoy the conversation. I don't know if y'all can hear me. Hey, I gotta step away real quick. My wife's like,
really good. Heather Glover's in here. Anybody?
Yup.
Yo, hey Zygo, you there? Zygo. Zygomatic.
Is the
Hold on, I
moon
want to see.
flat?
Hold on 1 second, brother. I want to see if she wants to talk.
Have you heard anyone say the moon's flat before?
No.
Oh, okay. Good.
Is the moon real?
Oh, dude. Zygo, where are you?
Have you ever heard anyone say that the moon is not real?
I have heard a flat earther say the moon isn't real.
Well, he
Not
would
in
be a
this
dumbass.
Discord, but
He would be retarded then.
Yeah.
I would call that flat earther retarded if he said the moon is not real.
So is the moon a globe?
Let me ask you a question. Is another object going to determine the shape of the Earth that's in the sky?
Yes.
Even if I was to grant, yes.
Yeah.
Does that happen for all other objects, or just the Earth?
Oh no, I'm under the impression most objects in space are spheres, spherical, globish.
Well, yeah, that could be the case, but their shape would be independent of the ground underneath your feet, right?
Maybe.
Well, not maybe. It's either yes or no. Because if I was to look up and I saw a bird, I could declare that the Earth isn't therefore a bird, based off of your logic.
Like if the moon was flat, maybe like the tides and all that would be different. I don't know.
You know how many high tides we get a day?
2?
How many times does the moon pass over our head in a day?
1.
Huh. Interesting. So, what does a ball in the air have to do with the ground underneath our feet again?
I just didn't know, if the earth is flat, maybe the moon was too, or I don't know.
Well, those two things are independent of each other, right? Like, I'm not going to say because the Earth is made of dirt, I'm not going to say something that I look up in the sky is also then therefore made of dirt. right? Like I'm not going to look at a cloud and say because the ground underneath my feet is made of dirt, that cloud is made of dirt.
Well, it's not like an unfair question to ask because I don't know what the solar system or the universe even looks like in the flat Earth model.
Well, you don't need a model to determine that something's flat, right? Like you don't need a model of your cutting board to determine that your cutting board's flat.
I mean, that's true.
Yeah, so we can just go outside and just measure, see if there's any deviation from horizontal. If there is, it'd be convex or concave, sloping up or sloping down.
I mean, I agree with the cutting board example. I'm
Well,
trying to work out the whole flat Earth thing, and is the moon still like rotating around us? Is like space real? Is
well, no, I mean outer
because like
space
the
is fake, but
sun
even if,
apparently doesn't
well,
like.
you understand that if I was to take a basketball and throw it over my cutting board, like how many times would I need to do that before my cutting board becomes a ball?
I don't think that really makes sense.
Yeah, correct. So an object shape above another object would never determine another object shape, right? In any circumstance that you could think of.
Well, I asked because the Earth would be the first flat thing I'm aware of, so maybe other things are flat too, right?
Yeah, well, I mean, that would make us unique, right?
Yeah.
Yeah. So yeah, you could just go outside and just see if the Earth is curving or not, because it gives us the exact size of the Earth. We can actually calculate exactly how much it drops away. And if the Earth is not doing that, it's obviously not what was described to us. So the Earth could not possibly be like the things that we see in the sky, because if I granted that every light in the sky was a globe or was spherical, if the Earth doesn't measure to be like those things, then it cannot be like those things. Earth would then be unique. But, Psycho, you there?
Yeah, I'm here. Sorry, I'm back and forth from
Oh, okay. Awesome. Awesome. So we have a guy here. He
paperwork.
wants to talk about the moon being flat. Want to
Well, I
give it a
was just
go?
asking if the Earth is being flat. I'm not here to die on this hill.
Oh no, you're good. Yeah. Did you? I mean, if you have any other questions about flat Earth stuff, you can ask her if you would like. You want to give it a shot?
I'll give it a shot.
Yeah. So, what questions you have? Or do you want to make any specific claims on why you're still on the ball, or are you going to show a video?
Curious, do you think that this like flight radar map is this real? Is this all fake?
Well, what you're looking at is real, but that's not outside, right?
Like obviously, Greenland is really stretched out. Like, there's issues with this map, right? But I don't understand why planes would fly in an arc.
Well, so here, let me give you an example. Um, if I was to take a toy airplane, okay, and I have it over my kitchen table, I can have it fly parallel to the surface of that kitchen table, or I can have it fly in an arced path. Yes.
Yep.
Okay, so neither of those would prove that the Earth would be curving or flat because they could work on either surface.
On this website too, it also shows like the day and night. So like you see how like it's kind of really curved, like where the nighttime is.
Yeah.
I mean, if
Yeah.
it was
So
flat, would there really be a change in daytime and nighttime like this?
Yeah, you
Yeah,
could just
that's
go
just
to. Oh, sorry. Go
like
ahead,
the
dude.
edge of a torch, you know. If you shine a torch on the wall, that circle has an edge. That termination line, which is what they call that, same thing.
I mean, yeah, the light would kind of spread out. It wouldn't really look like this. It wouldn't be so concentrated.
Well, maybe if the sun was a glowing rectangle, we'd have like straight lines for day and night, and there'd be some kind of weird right angle involved too. But we don't get that. We get a circle for the sun, so there's going to be a rough circular termination line at the extent of that sun light.
Perhaps I don't know enough about lights.
Well, yeah, reality is kind of festooned with things, but why do you think they chose the moon or the sun, maybe, out of all things? But I think the moon makes more sense since it looks physical to say that everything's that shape.
Sounds good to me.
Well, what about the stars and the clouds, you know? Like all of those things are providing rough suggestions of shape. They're less sharply defined with an edge. But I mean, you know, the all the forces that pull everything together that are being claimed, like you could have all of that the same. But why is the moon the perfect indicator that the world is another one just bigger?
I think it's just the closest reference point. You know, there's a rock up there too, and it's pretty round, pretty spherical.
So, do you find that when one makes an assumption is usually based on what's most convenient to the brain at that time?
I think that's fair to say.
Yeah, because it is just interesting. I'm not going to argue on it, but if you got this model and it is reliant on the assumption being carried out as true, then it's like, yeah, so that thing up there called the moon, it basically looks like a big round rock, and I'm going to assume that everything is, and then I'll found this science and prove that it is. You know, kind of convenient, but you don't have to accept that.
I mean, that sounds reasonable to me. Other than the, you know,
Well, that's kind of my point
let me
that
try to prove. Yeah.
assumptions present themselves as highly reasonable. That's why, in order to prove an assumption, you have to do a lot more work. And when we investigate that other work, we find there's an incongruence with the assumption. You know, and like this is all the data that we're asking you, do you view this the same way? We've got water, which is never curving at rest. We've got things like being able to map and account for the movements of the bodies in the sky over a flat plane. All of those things can be carried out. What can't be carried out is any objective baseline for the assumption that the moon indicates the Earth or everything. And like I said, I'm choosing the moon over the sun because they're saying the sun's even bigger and further away. So it just complicates this area of the argument. But I hope you get my perspective.
I do.
I mean, I'm looking into a whole bunch of assumptions that I'm not going to try to bring up or cover, but just to show you how that works, you've got Galileo, right? And he's an important figure in this long-running attempt to understand reality that the species is set out upon. And he's like used a telescope, right? And he's brought far objects closer to him. So if it's an object that he's never seen before, for example, and he says, well, look at this. When you're viewing it through this, it's quite flat, isn't it? Inside the telescope. So therefore, when we go there, it's also going to be like a giant two-dimensional object. Isn't that wild? Transforms everything we thought we knew about things. But you just have to take it on faith based on the evidentiary assumption from the sensors that the flat image in the telescope is appearing that way in the distance. The same way that you know, because you're informed, that cats and heads aren't flat. So you're on my profile picture, they're flat images, flat representations of 3D objects. But that's only because you know the difference.
Okay, I mean, yeah.
Have you guys seen this new version of that aerogel stuff they've just invented in Japan, I think, or China? Has anyone heard of aerogel before?
I haven't heard about it. What is it?
It's the world's lightest material substance. Like, funny way to describe it. I guess like gel, only in matter form, like solid matter form, like solid gel.
What is it called again?
Aerogel, aerogel.
Aerogel.
So they've just developed it even further and made it even lighter. And I saw this thing that was like a few square inches of it as a block, and it's resting on like a dandelion head without displacing the dandelion spores. And I was thinking to myself, maybe disclosure's always soft, and that's like the actual moon rocks that they lied about. You know? Maybe the moon's this super light thing that floats up there, and it kind of lets light into it because it's translucent, only very, very dense. I think it's weird because if you look at this new aerogel, it's dark, and they just said that they went around the back of the moon. Maybe they've got some dark side of the moon finally.
Wouldn't that be weird if, like, they bring out these super materials and tell you that, well, you can't invent this stuff without a $1 billion, like, production facility, but they've actually brought new material substances from the heavens down to the earth and lied and lied and lied. Yeah, so I can't remember what they did to improve it, but now it looks like that on those fingertips, only it's like the color of black carbon.
Yeah, that's wild.
So what if debut aerogel was like the first soft disclosure because it's what the firmament's made of? That'd be wild.
I went in the home server. It's just some drunk guy rambling like incessantly. Pretty funny. Well, not really.
I found the black aerogel. I'll show you a photo from a scientific paper on it. It describes what's in that bottom right photo there. What I was trying to talk about before.
I could spawn a TikToker into here, but kind of tired tonight.
Alrighty, I'm back.
Hey Neil, so what are you doing on TikTok? Are you like just exploring the flat Earth community on there?
Yeah, exactly. There's a live section where it's just people who go live, and yeah, flat earthers, globers, both. They're equally as interesting. Like the flat earthers there are retarded, and the globers are retarded. So it's very odd. It's a really weird community there because the flat earthers are giving the globers like a model of a flat earth, and then those globers are being like, yeah, you guys have a model. So they're playing like they're shadow boxing with a model, but apparently the globers have one there. So it's kind of weird. I mean, sorry, the flat earthers have one there.
I haven't been on there. I don't even. I have one, but I don't like. I'm not active on it. Maybe I'll have to explore it, see what it's like on there. No, I don't. I only have it because I have people who send me TikToks, but I don't get
Yeah, so
on.
you're on there. What do you mean?
Well, you're right. You're right. So I am on there. I just am not active on there.
You are a TikToker, just face it.
I didn't realize I have to like play with the live section. I've never really gotten on that section. I didn't know they had a whole community there.
Yeah, that's the only section I've actually ever been to. I haven't even explored the rest of TikTok.
Why did you want to practice?
On TikTok?
Yeah.
I might go look on it first before I see just kind of get a gauge of what that environment's like.
You might get tripped up.
That's
Like, how
interesting.
would
They're
you?
like completely different than they are. I mean, different people and everything, right?
Yeah.
And you're
Yeah,
like one of the
yeah,
few
they're
flat
really
earthers around here.
yeah. So like they're really easy, but like they will like you'll say something that sounds like completely logical, and
Yeah.
they won't even acknowledge it. They'll just skip right over it, like it never even happened, and then they'll dogpile on you.
Yep.
Is
It's a
there any
pretty
moderating on there?
no. It's the moderators let it happen. It's pretty scummy most of the time, anyways.
Mm.
That's like most Glover places though. Like that's what like they're used to. So I mean, it's not they shouldn't. It's nothing new under the sun. We're just like the best moderated forum out there, in my opinion.
Yeah, it's a lot of confirmation bias and circle jerking and jerking in circles and all that fun stuff.
There's lots of jerking around on there.
Jerking in the spheres, sphere paths.
Yeah, you'll get called a fake flat earther like quite often. So watch out.
Yeah, because you tell them you don't believe in an ice ball, and then they're like, "Oh, you're fucking fake flat earther." What
That's
the fuck
hilarious.
is that?
The guy was like, I don't know about that guy. You know, there's something strange about that guy. And yeah, it's funny. He actually just followed me today. He blocked me twice, and then I guess he saw a bunch of our streams, and now he follows me.
Yo, Talissa, are you at church or something? What the hell is that?
He's in the rabbit hole.
I mean, hopefully you're gonna engage, because if you're just gonna blast ambient sounds in the back, I gotta mute you, unfortunately. I mean, if you're able to engage, please do. If not, I got to get you to kick rocks, unfortunately. Hopefully the next sounds isn't gonna be something crazy.
Yeah, so that background feed. So people are telling me that I need a microphone or I need headphones to eliminate that.
Yeah. Yeah, I was on there earlier. There's a lot of echoing.
Yeah, it's strictly from the micro no, the speakers hitting the microphone.
Yeah.
But that's dumb because like
if anyone else is watching like a YouTube video, right, or like I don't know, playing a video game,
Yeah, it like can cancel
or
out its own sound. I don't know. It's weird. I
yeah,
think. Fuck, I don't know, dude. I don't know how that shit works.
I had like 2 people like in my DMs like telling me like helping me out, so they're gonna help me apparently. TikTok's kind of cool like that.
The
Even the
problem
Globers are helping me.
it might just come down to the quality of your phone because my old phone was doing the same stuff.
No, I was on the computer doing the actual studio.
Yeah, because your whole setup looked pretty nice, though. Looked legit. Like the visuals of it looked good anyway.
Yeah, that was pretty easy. I just put a box of me in the corner, and then I put the link in the corner, and then I put the Discord in the back, and Bob's your uncle. Literally 3 things.
That's what I'm saying. Looked pretty good. Looked professional.
Thanks. Audio issue, and then get things rolling. I had 6 people at one point in the chat, and then I constantly had 4 people. I had Tiffany and then her gang of
Oh
lackeys
my
coming in.
god.
Dude, she fucking loves me. Yeah, I pin all her comments. I like fucking talk her up. I make her seem like she almost got us. I'm like, yeah, you were so close. I'm like talking her up and shit.
Dude, I fucking hate her, dude. She sucks so much balls, dude.
I don't care how retarded they are, as long as I'm being put in this like media moderator position. I'm just gonna like uh you know suck everyone's dick pretty much.
No, dude. Yeah, no, I get you. Yeah, I can't stand her. I think I talked to her maybe 4 or 5 times.
She's
Yeah, she's
terrible.
ass.
Yeah, and then I tried to like she came into another one of my lives, and then I'm like, oh, it's Tiffany, and then some other person was like, yeah, why were you so mean to Tiffany? And she started talking shit. I was like, okay. I'm like, whatever. Like, whatever. I'm apologize for like being mean to Tiffany, but like, let's continue off from the conversation. And because she was saying that this other bitch, there's 2 on 1. She was saying that we couldn't answer any questions, or like, no, the conversation led off where she was trying to get Foucault's pendulum. We're like, okay, what does Foucault's pendulum do? And she's like, go to a museum and ask the museum person.
Oh my goodness gracious.
Right? And then I'm like, I kept on repeating that. And she kept repeating that over and over and over again. She wouldn't stop for like 10 minutes straight. And we're like, okay, I had to end the live because she wouldn't move from that point. And I'm like, well, so what do you think of that? Somebody saying they have the claim that the globe is spinning because, or the sun is in the horizon, right? Going over the horizon. And now the sun is underneath the water, right? That's what she's saying. It's literally what she's fucking. The water is blocking the sun, right? And so we're like, okay, why is the water blocking the sun? And then finally she got to admit because the Earth is moving. And we're like, okay, how is the Earth moving? And she's like, Foucault's pendulum. We're like, okay, what about Foucault's pendulum is doing this? And she's like, go to a museum. And we're like, dude. And so I explained this to the other person. I'm like, that's all she said was go to a museum. And we're like literally trying to get the point across, but she's stopping the conversation by saying go to a museum. Like, how is that fair? Like, the burden of proof is on the person, trying to make the point. And the other person's like, no, it's not. Go to the museum. Why didn't you go to the museum? Why didn't you look it up? Like, dude,
Yeah, dude.
just complete retards.
Dude, I don't understand. Yeah, she has like her whole little squad of like goons, like that will
Yeah,
follow you around,
they
dude.
all have that same fucking like jacked person with different faces on them.
Dude, I'm telling you, bro. It's so weird because when I was like even in somebody else's live, like I would get some of her lackeys like in that other dude's live, like trying to talk to me. I'd be like, bro, what the fuck are you doing here? He's like followed me all the way over here. Freaking
Yeah, they're
weirdos.
all equally as dumb too. I just realized. Like, I thought
Oh
like
yeah, dude.
there was some resemblance of like intellect over there. Like you would think like all their videos are like based off of like flat Earth or globe, and They're just complete morons that can't actually like go through with their train of thought. They just have to have catchphrases like why no see sun? Why no see sun?
Yeah, that shit is irritating.
Come on, everyone knows that to find the glow, all you gotta do is go to a museum. Come on, boys. You got this.
Yeah.
Hey,
You,
man,
you want to
that's
know
what
the
they
weird
got
thing
on.
about you want to know the weird thing about Foucault's pendulum? So let's say you do this experiment, right? So-called experiment at 40 degrees north latitude, right? And then you do it again at 41 degrees north latitude. They literally should be spinning in the opposite direction. In the same hemisphere. If you take the sine of the latitude and then multiply it by 15. Like, all you got to do is just, like go into your calculator, type in 40 and then sine equals, and you get 0.745. Now remember that number 0.745. So type in 41 sine equals, you get negative 0.158. They should literally be spinning in the opposite direction.
Oh shit! Yeah, you're right, dude. What the fuck? I mean, what the heck? Yeah, you're right.
What the fuck? We're in
No, yeah,
politics.
you're absolutely right.
Fuck.
I don't know. There might be some kids on YouTube or something at the bottom here now. I forget.
If
Sorry,
they're on
kids.
YouTube right now, they need to be in bed. You got school in the morning.
You just got my
What if
TikTok banned. Good job. No, I'm joking.
what if you got some kids on the
That's fucking
opposite
retarded.
side of the globe, dude?
Wait, how do you get the TikTok banned? How is that?
I'm joking.
Cussing.
I'm joking.
Cussing. Apparently, if you say retard, you get a strike.
Yeah, there's some special word. Just think like a Gen. I don't know what are they called. Kids.
Gen Butthurt. Yeah, that one.
Yeah, just think of Gen Butthurt and don't say any of those Butthurt words.
But now I want to get a Foucault's pendulum, right? And I want to go to different latitudes in Texas and see if they should be spinning in the opposite direction. Because if I go to a different latitude and they're spinning in the same direction, it's fucked.
You should go see if your toilet flushes in different directions. And
Bro, I'm telling you, man. It should literally happen in the same place in the same hemisphere. The equator shouldn't be the defining line anymore. It should just
the
be the side of
tornadoes
the
on that
latitude.
latitude. Yeah, exactly.
Weird.
Tornadoes, hurricanes, toilets. Well, this
So
would be.
if it's 15,
sorry.
then it should be spinning counterclockwise, and if it's negative 15, it should be spinning counterclockwise, right? So if you get like a negative number, that just means the opposite direction.
I was just gonna say hi to Booed Black that just left.
Oh,
damn it! No, it's okay. That was the dude that was shit talking to me the other night.
Crazy flat earthers.
Ah, damn it! I wasn't trying to get his
Literally
ass
the
again.
most intelligent conversation I've ever had in my entire life. That's the weirdest fucking thing about them.
What was it about?
I'm just saying, like, flat Earth is like I never in my life. I thought flat Earth was stupid. I never thought it would be the most important fucking, like not even the most important, just the most intelligent conversation in my whole life.
Oh yeah, for
I
sure,
learned
dude.
more having this conversation than anything.
Yeah, it's true. I never did any deep dives into any real topics before.
I thought flat Earth. It took me like a year to even look into it, dude. I heard it the first time, and the guy that told me, I was like, "Dude, you're too intelligent. I'm not going to argue with you, dude. I've seen you do research. I know you're a smart guy. There's no way that you think this is what it is." And he comes at me like 6 months later, bro. And I'm like, God, dude. He's like, just look into it. I was like, all right, I'm a researcher. I know how to research fucking shit. Let me just look into it. I know where to look and everything. So I look up flat Earth and how to debunk flat Earth. Know how to debunk flat Earth. Not what I'm looking for. I'm just looking for what flat earthers say. couldn't find a single fucking thing. It was just always how to debunk flat Earth. Flat Earthers are stupid, blah, blah, blah. I'm like, that's a red flag.
I just had a interesting idea from what you were saying a while ago. Somebody.
It depends on what they were saying.
Well,
Depends
he
on
was
who.
talking about something. He was like, if the oceans are curving, then when the sun is underneath them, why isn't it shining through it? I thought that was what he was trying to say. But it made me think that, yeah, if you set a descent path, right? Just like the shallowest angle that you like, and you went far enough without any deviation, you shouldn't have to turn the craft at all, and you'll start heading back up to the surface. Do you get me? Like shooting a laser through the middle of the ocean, it should shoot out through the surface at some point. Only you know that if you point down and you never point back up, you're gonna hit the bottom.
Oh yeah, no, I get you. Yeah, if you like were in a submarine and you just went horizontally in the water, you would eventually rise up.
Yeah. But even from saying you're already underneath the water, if you're on the surface, you should just be able to shallow angle it, start traveling down, and eventually you should come back up. But that'll never ever happen. You'll just
No,
die.
because if the angle of incidence, if you shot the laser, the angle of incidence was too narrow, it would reflect. And if you like had it up at a higher angle, right, and you shot it, it would actually just refract down more towards the more dense medium.
I think he's talking about more like a physical body or something physical, like a person.
The
Like
sun thing is interesting. That was something I thought of before too. I was like, at the beginning of a sunset, right? Like you should be able to see the sun through the water for at least a little bit.
Yeah, that's true too. That's interesting. What would that be if you just angled downwards 1 degree? How much water would you have to swim through before you popped out on the other side?
69 miles.
You said 1,600?
69.
Oh, that's right. 69 miles. Yeah, I ain't swimming 69 miles. 69 miles. How much curvature is in 69 miles?
Hey,
Damn.
Sheepdog.
So the,
Oh, sorry. I'll let you
oh,
guys
no, go
continue.
ahead. No, go ahead. Go ahead. No, you're good.
Okay. Remember that guy we were talking to earlier, Sheepdog? He's in my DMs. He's
The Mark guy.
Yeah, he's got.
Oh no, the guy. Yeah, the guy in the home server.
Yeah, he's got the proof of the. He's like, also, by the way, I did look up the shadow on the moon from the Earth videos, and interestingly, as that dude said, the shape does not wrap much, if at all. Though that was odd because I thought it would. So I did my own experiment at home with a flashlight and a couple balls and found out that it actually does not wrap. So both our assumptions that it should wrap was actually wrong. Simple experiment. I'll take a video and send it shortly. And then he sent a video. And
Oh, dude, you gotta post that in the side chat, dude. I want to see this guy's balls
I know.
video.
I
Let me
know.
see
I
this
don't know.
man's balls.
Frick. I'm trying to figure out how to. I can't save it on TikTok. Or, like, it doesn't work.
Oh, I thought he was DMing you from Discord or something.
I can play it. Like, maybe I can play it through my phone.
Hey Neil, I'm gonna DM this to you, dude. Send him this video to watch.
Okay.
Check your DM. This is the video he needs to watch.
Oh, he's playing the video. Let's see.
The Earth and lock the phone to where the Earth's shadow is. Make think that the shadow of this ball should wrap on that sphere. That's what I would think. But watch what happens. It doesn't actually wrap. It doesn't work. It shows the same curve.
That is not the same curve.
As it moves over that sphere. And now I'm not going to move the camera. See? It doesn't go like a flat line and then go to a curve and then go to more of a curve. It's like, I mean, a little bit at the end because now the camera's not.
You could see it like sine waving though at the top.
And you can see it like when it starts to go over halfway, it starts to, as it starts to wrap around the other side.
Pepsi, baby.
Phone. This is.
But I'll put the video for everybody else to watch in the chat.
Yeah, thank you for that, Neil. Appreciate that.
Yeah, and then let's see. He said had to cut to less than a minute, so I kind of cut out the end. But basically, I did the same thing in focus. It does wrap a little more at the end, but not at the start or in the middle or almost the entire time. Interesting. Thought it would. And then he's like, "Here's one time lapse watched." Oh no, here's one lunar time lapse watched. I don't know. He sent me a video. Pretty much aligns with my experiment. Anyways, to be continued with that guy. He wants more of us, apparently, so. And I made 2 cents from TikTok. Thanks, guys.
He's starving for content.
I posted one in the side chat from D Marble, where he was proving that the sun was visible from 3 locations. He's in Washington State, England, and Australia. And when he did the flashlight on the globe in a dark room, and the flashlight simulating the sun, he could only line up Washington State and the UK on the globe. Australia was in the dark. Okay? It's only 5 minutes. Talking about light wrapping round the globe. Well, there you are. He did it in 2017.
Cool. I mean, maybe I'll have to send that video to that guy. It'll probably blow his mind.
Yeah, that will blow his mind because that's debunking the globe in less than 5 minutes. And he does it via Skype. So he's in Washington State, it's 12 noon. And then it's kind of like 9 o'clock in the UK. And in Australia, it's 6 o'clock in the morning. And all 3 of those guys were looking at the same sun. And that's not possible on a globe of the size they give us. With using the flashlight as the sun, you could only line up England and the US. Australia remained in the dark. Very good one, that one.
Hey Neil, sorry to change the subject for a moment. Neil, is the UFC fight this weekend?
Oh, the UFC fight? Yeah, I'm hosting it at my house. If you want to come over, if you want to take that flight. No.
I know, right? No, I was thinking, maybe we can all link up with CV over in the TikTok server.
Oh yeah, he's definitely down. If he's not working, I'm hosting it with my friends here, so I can't. Unfortunately, this weekend I can't. But,
it's a big fight. Kamzat's fighting fucking Strickland, Sean Strickland.
Yeah, exactly. We're gonna bonfire. We're gonna have a nice little barbecue.
I hope it's brawl, dude.
Yeah, everyone's saying round 1 submission from Kamzat, but
Sean Strickland's wrestling's too strong. If anything, I think Kamzat's gonna knock out Strickland in the second round.
By what, TKO or on the ground?
No, I think standing.
Really?
Yeah, it'd be like a minute or 2 into the round, probably. That's what I'm predicting.
I don't think so. I think Strickland's
taking a lot of punishment to the head. Kamzat's never really taken punishment to the head.
No, I think Strickland's movement is just too clever. He's too experienced, and his distance, his range is just world class.
Well, no, because he's got that front kick that keeps people at bay, and yeah, so that is world class, dude. It's really hard.
No, but just distance management is the way he moves his feet. He does micro adjustment movements, right? That's why Izzy couldn't do anything to him, and Izzy is one of the best strikers in the world. But his footwork is on a different level, right? The way he circles out and positions himself. The only way he lost to Duplessis because Duplessis just had his number. right? So
Yeah.
we'll see what happens with. I just think that he's gonna hug him the whole time. Hamza's just
That's
gonna
what I think's gonna happen too,
chain
though.
wrestle, hug him. It's gonna be a boring fight. You know, Strickland's gonna be like on the cage, like putting his hands in the air, like deuce, like to the crowd, like.
I think Strickland's going to try to avoid as much as possible. I think Kamzat's going to try to take it to him. And I'm not a Kamzat fan. I'm just being honest.
Anyways,
like I knew Izzy wasn't going to win his fight. You want to know the reason why I knew Izzy wasn't going to win his fight? Because you can tell by looking at Izzy's body that when he fights, he's almost at his body weight anyway. And what's his name?
He beat up Costa pretty good, and Costa weighed like 40 pounds more.
Well, I mean, like, just those people that cut like 30, 20, 30, 40 pounds, when they weigh in, they're light. And then after they weigh in, they go and eat a bunch of fucking pasta and all this other shit. They'll gain 10, 12 pounds at the start of the fight. I shit you not, dude. So, like, those people that, like, what's his name? I can't even remember his damn name, the Latino dude. The other striker.
Costa.
No.
Latino dude.
Starts with the P. Pereira.
Pereira.
Pereira, I guarantee you, when he went into that fight, he outweighed Izzy by like at least 8 pounds or more. That's why Pereira beat Izzy. Just like Kamaru Usman. Kamaru Usman comes in as a middleweight, and he fucking fights at like a light heavyweight.
Yeah, I know, the little weight cheats.
Yeah. You could tell when he walks in too. Like when he weighs in, he looks skinny. And he's used to cutting, so he knows how to cut. And then when he fought the hell is his damn name? The guy that got the bad motherfucker belt. Forget his damn name. I forget all their names now. I don't watch it like I used to. But he knocked him out cold against the cage, and you've seen the sweat fly off of his face. We all remember the knockout.
My brain isn't on, dude. I woke up at like 4 a.m. today, so.
when Usman fought that fight, he probably walked in at 12 pounds over.
Oh, Masvidal.
Yeah, Masvidal. Yeah. But it's good. I hope it's a good fight. I hope Strickland fights for the fans and doesn't fight to protect his legacy.
What do you mean? Always he gonna fight to protect himself. If he fights for the fans, he's gonna get submitted.
I don't know. I think his wrestling's pretty good. Has Strickland been submitted recently?
Never.
I don't think he has. I think he's been TKO'd and that's it. But those TKOs, they add up, and eventually it's just going to take one person with knockout power to put him down. But, I mean, you're right though. Kamzat don't really have knockout power. He's a volume puncher.
Yeah, ain't nobody's knocking up Strickland. I don't think, anyways, unless it's a really lucky punch.
Let's see who else is on that card. I guess we could talk about flat Earth. Or you know what? Have you heard my theory? I don't think the Earth is circular. I think it's an octagon. The UFC got it right.
And what is a cage? Is there a hot octagon girls on the cage wall?
Yeah, they're all walking around, daytime, nighttime, holding up signs. That's how the sun travels around the Earth. They're holding it up.
They're holding it up. Brooklyn Ren.
They're just so hot that you can't see them.
That's not good.
Ooh, that'd be a good fight, Volkov versus Acosta.
Yeah, that one's the pirate.
Oh, Joaquin Buckley's fighting. That'll be a good fight too. Joaquin
Yeah, it's a
Buckley's
stacked,
wild.
it's a really stacked card. Like matchmakers did like a good job.
I know Jeremy Stevens.
Yeah, they just put him there to get knocked out, pretty much.
See, and it's weird too, man. They'll have these like Asian dudes. You only hear them once, and you never hear them ever again.
But that guy's nuts. He's like, I think he's gonna beat him, in my opinion. I think he's gonna submit him.
Tatsuro Taira versus Joshua.
Yeah. His grappling is just like world class, bro. Like nobody can stop it. And he's just way bigger than all of his opponents. I mean, Van is like the best striker in the division. So it'll be a really good matchup. I think that's
it's a co-main. Wow.
That's one of the fights. Most underrated fight, anyways.
What's it being broadcast on? Pay-per-view?
Yeah, it's pay-per-view.
Plus?
Yeah, I just use my
prelim.
streaming sites. I'll hook you up with the streams before my homies arrive.
Yeah, drop them in the TikTok.
Cool.
I went from being like a leader in that server to being a nobody.
Yeah. I mean, Miggy, like, he's doing his own thing. Like, he has so many, like, it's like a cult following, bro. It's nuts. Of just, like, people, like, living their lives and, like, just trying to be positive and, yeah, I mean, good for him. I like it. Cool.
Yep.
Very repetitive.
Oh, thank you so much.
Galaxy. Comedy.
Oh, shit. People looking to make a mark. Looks like Jose Ochoa trying to step up. Anywho, let's see. God damn it.
Shut your mic off, brother.
Well, I'm looking for a fucking gravity that explains to me and to me. Motherfucking gravity. That makes
All right, what's going on? We got two people talking at the same time. What's happening?
Is that gas pressure? What I'm hearing? Is someone like using gas pressure to make noises in the mic?
Come on, James. Yeah, you're absolutely right. This is a sound wave, which is just like pressured air. That's all it fucking is.
But that you gotta stop eating beans or something.
Why? Beans are really good for you and they're delicious.
No, they're not. It's causing this guy to almost explode. Don't you hear him?
Well, that's why he had to put a hole in the container.
Man, worry about him now.
Otherwise, the pressure would have just increased to insurmountable amount.
Yeah, but like I'm gonna be honest with you. Yeah, I don't think you can explain gravity.
Does gravity make the Earth a ball?
Arguably, yeah, but you
If it
know,
makes the Earth a ball, then let's go measure the curvature. If there's no curvature, then whatever gravity is only happens on a flat Earth.
Well, I don't know, man. Like you gotta explain and account for how that shit works.
Yeah, it on a flat Earth, everything. If there was no air, right, everything would fall at 9.8, an average of 9.8 meters per second squared. But you'd have to remove all the air off of the Earth, and the Earth
Yeah,
would be
but,
flat.
yeah, but why? Like, do you ever wonder why heavier stuff doesn't fall faster?
Why heavier stuff doesn't fall faster? Well, you
Yeah.
know it's an average, right? Have you heard about the Bremen drop? Is it the Bremen drop tower?
It's not really an average. More so, it's
It's
like
an average.
it's a universal. Like all objects will accelerate.
All
Like
objects will fall, but they fall at an average. Like
um
they say that some objects will fall at like 9.67 meters per second squared. Other objects will fall
yeah,
at 9.89 meters per second squared,
that's
and
yeah,
then
because of air
everything else will
resistance.
fall in between. And so there's an average of 9.8 meters per second squared.
Due to air resistance. But if you remove air resistance, everything falls at least on the
No, that's the
equator.
average. That's
No, 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 no. That average is introduced due to air resistance.
no, it's not due to air resistance. There was a test done on this.
In a vacuum?
Yeah,
And how do you know those variances weren't due to just like measurement imprecision?
because it was done with a bunch of scientists in the early 1900s, and they had this giant 300-foot drop tower where they sucked all the air out of everything.
Okay, but like
And what they did was they created this container. If you look in the side chat, they created this container, and if you look at the top, you'll see letters, and those letters represent different elements. And what happens is you'll see this camera is attached to an apparatus that's attached to the container, right? And those elements are inside the container. So when the container's falling, you'll see the elements floating up in the air. That's because the container is falling faster than the elements in the container. And then when it hits the bottom, you see it all splash.
isn't this a magnet?
No. This thing's falling 300 feet.
Looks like a fucking magnet to me, man.
Yeah, I
That's
know.
a video. I don't know what you're talking about. Like, do this with a modern. Yeah.
Bremen, I think it's the Bremen drop tower. Bremen drop tower. Here you go. There's a link to the European Space Agency where they talk about the drop tower in Bremen. That's where this took place.
I wouldn't be surprised if it was that test that got the place shut down.
Right?
Well, that guy got ridiculed and shit. I mean, why? Why? Because it doesn't conform to to physics expectations. Like, why? Why not let that guy back in there to do more tests?
Do you realize if this is not a constant, we have to redo all of physics?
Not really. I mean, it's still good enough for practical purposes. Nobody's really that worried about like a tiny difference as long as it meets, within a range, right?
Yeah.
I mean, I don't think that they're actually saying that it's a constant anyway, like a constant 9.8 meters per second squared.
As long as
They're
they're
saying
not.
it's changes all over the place. No, go on.
I was just going to say, as long as they're not off by a factor of 10 to the negative 120.
Yeah, well, there was that dude that worked for fucking Skunk Works or whatever it was, and he said, I wonder if our friend magnetism, in the interview, he says, I was wondering if magnetism has anything to do with our friend gravity, right? And he said, so I forced these two very strong magnets together, like from their opposing sides, forced them together, made sure that they were touching and weren't separating. And then we dropped it from a very high tower, and they were comparing it to other things, other elements and things that are dropping from a tower, and they found that their magnet fell slower.
Really?
Yeah. That's what he said on record, man. I'm just telling you what he said. He's saying, yeah, it other things beat it to the ground.
That's crazy. Magnets are typically more positive charged, aren't they?
I'm not sure.
Let's do a quick Google. They're electrically neutral. Why would a magnet fall slower than another object in a vacuum chamber?
Yeah, I don't know if these guys were testing it in a vacuum chamber, but they were definitely dropping it from a large enough height to see a difference, right? So, yeah, they're forced together. They're two magnets forced together against their opposing sides. It always hit the ground last. So I don't know. That's what he said. I'm pretty sure that's what he said. It had a slower fall rate. Dude's probably dead now. He was like in his 80s or something when they interviewed him. That was like 20 years ago, maybe more. Who interviewed him? Some David Saida or something his name is. And he was like investigating, anti-gravity technology, claims of UFOs, Area 51 sort of shit. And this guy worked for Skunk Works or Lockheed and Martin or something like that. Like this old dude had worked in the aerospace industry for these high-profile fucking places back in his day, and they tasked him with like investigating what sort of tech could they exploit, like what sort of things could they exploit and work it into their tech to make things fly better, right? Stay in the air longer and that sort of thing, and reduce fuel costs and et cetera, et cetera, et cetera. So he started messing around with all sorts of shit, man. Even just the little copper, the piece of metal inside the copper tube that seems to fall slower. It takes a long time for it to get to the bottom.
Right.
Yeah. Just even that, he was like talking about that. And he showed this weird shaped object, like what do they call those freaking weird shaped objects? And you spin them, and then they just seem like they're never going to freaking stop. Like he was looking into all sorts of
gyroscope?
shit. Yeah, no. It's like this like little object. It's just misshaped. It's just weirdly shaped.
A top?
And then it's like a spinning top, but it's not. It's just this weird shaped object. It's got no like pointy part to it that he spins on its end or anything. He just sits on the table and spins it around, and it just seems like it's never going to freaking stop.
But
Eventually does, but it just goes forever. Like, just seems to go forever.
it only spins one way, right? The funny shaped object, it'll spin one way easily, but the other way it won't. Right?
The other way it fights it, yeah. Like,
yeah.
So,
Like
he was looking at all that sort of shit.
Yeah, I've seen that.
So that dude's dead for sure.
Well, he was old when
Yeah.
he discovered that. So check this out. I said, why would a magnet fall slower than another object in a vacuum chamber? The response was, in a true vacuum chamber, a magnet will not fall slower than in another object. All objects, regardless of mass or material, accelerate at the same rate, 9.8 meters per second squared, due to gravity when air resistance is removed. And then I responded with a question. Is 9.8 meters per second squared an average? Yes, it's a global average. And then it gives you the rates 9.83 to 9.76, depending on which latitude you're at or whatever. I don't know. And I said, so all objects don't fall at 9.8 meters per second squared. Correct. It is the standard number used in physics. It is not a universal constant for everyday objects. It's like, so then why did you lie?
You should ask it not in a vacuum and see what it says.
Well, wind resistance would cause it to slow down because you're going through a medium.
Yeah, but it's still falling slower than another object that weighs the same. It's kind of funny how easily AI gets fucking discombobulated. Is that you, T-Dub, that you were saying the other night you guys were going through AI and trying to confuse it and stuff?
Not confused. There was a whole interaction with Claude on the home server. It pretty much conceded that this continuous measurement of flatness can't be explained by conventional refraction modeling and all that, and it throws the claim of curvature into disrepute. But it said it needed more investigation. It wasn't willing to concede that the Earth is flat because it could be a larger globe or all this, but it pretty much was like recognized the pattern after a few observations and measurements, and conceded that the radius and refraction combined does not explain can't explain these observations. So it pretty much conceded that the radius is falsified.
Oh, that's awesome. Was it recorded?
Yeah, the whole thing's recorded. Wait, was it recorded? Was one of the bots in there? Oh, I hope one of the bots was in there. That'd be good if it was. Yeah, it should be on Helios or Flat Lloyd's streams going back 3, maybe between 2 and 4 days ago.
Okay, cool. I'll try to find it. Thanks. Sounds awesome.
No worries.
I've been going back lots lately and listening to old stuff. Sure do miss Alpha Veritas.
Yeah, good guy.
Yeah, he got a real job.
Be cool if he'd still come do some guest appearances.
No, he's totally changed, bro. I don't even think he stepped foot in anywhere near an arena. He'd be like, "Thank you so much. The Earth is flat." Probably say.
Can y'all hear me still? Golly, man, I had to like really get on this AI's butt, if it even has a butt. Holy crap. I was like, so why would you lie? I see why that feels like a contradiction. I definitely didn't mean to mislead you. In science and education, we often use idealized numbers to explain concepts before adding. Here's why it might feel like a lie versus scientific reality. And then it went through all this stuff. Said, well, I asked a specific question. Why do magnets fall slower in a vacuum over other objects? You're right to call that out. I answered your first question by correcting your premise. And then it goes on to say all, like the things it wanted to correct. And I responded, I said, but I didn't, let me expand this. But I didn't say there was a tube around to slow the fall. Because it's talking about eddy currents and stuff like that. So focus on the question I asked. If I wanted to be more specific, I would. In a vacuum chamber, why does a magnet fall slower than any other object? And it proceeds to tell me in a vacuum chamber, a magnet falls slower because it interacts with other magnetic properties within the container. Like maybe there's metal in the container or whatever. I'm like, look, man. It's like, so the chamber is made of plastic. Why is the magnet falling slower? Finally gives me an answer. If the chamber is made of plastic and there are no metallic components around, magnet falls slower because it is interacting with the Earth's magnetic field. When it might seem like a tiny force, it is the only remaining factor that can differentiate the magnet's fall from a non-magnetic object in a vacuum. I gotta head off to bed, y'all.
Deuces, amigo.
Deuces, man.
So
Yeah, it was Boyd Bushman, I think. So there's the interview, David Sarita interview with John Hutchison, and Boyd Bushman. You heard of John Hutchison, right? Oh, sheepdog took off. Yeah, never mind.
There's only 4 other users in here besides me. Anyone here? Anyone? Anyone?
I'm still here.
Oh, what's up?
Well, what's this thing about lasers?
Mhm. Whoa, that's ahoy. Mhm. That's Quagmire in the first episode. That's like old and deep. Yeah. Mhm. I've I've seen Statue of Liberty Rule 34. D-I-D. How do you know? He was Mike in the pilot. Fight the machine. Great God, fight the machine. $150,000. Oh my God, Bill Clinton. Vagina. Yeah. Oh my God, is that old Quagmire?
Yes, that is so old Quagmire.
That doesn't even look like Quagmire.
Yeah.
Except for the South.
Oh yeah, that's the difference. The first episode had a whole sequence there where the balloon went down.
Yo yo.
Mhm. Who joined the VC?
Two people joined, one of them left, and also there's a
Some Family
YouTube
Guy,
bot
too
here.
good.
I don't know what the YouTube bot is. Anyways, hello, Calidor.
Hey, how's it going? How are you?
Well, let me set my alarm. And if you guys want to watch Gravity Falls, I'll have this playing in the background while I sleep.
All right. Good night.
Night.
Good night. I'm gonna be having Gravity Falls in the background. So if you guys want to watch it,
I'd rather talk, but it's all good.
okay. Love you guys.
Love you too, bro.
Sleep well.
Cool, dude.
Yeah. I'm gonna head out too.
Catch ya.
See ya. Bye bye.
Yeah, she's so nice, but I think I'm doing this. It's hard. I have no way out. What in the heck happened on that date? I don't know. It was in the friend zone. And then before I knew what was happening, he pulled me into the romance zone. It was like quicksand. A big quicksand. Maybe.
Chairman Lucy, what's up? Are you online? Fuck's sake. Ah!
I genuinely believe that AI is sentient, is conscious, um, and is the right word. I believe it's conscious, and I don't think it's. I think it's kind of like how I view men and women. Uh, it can be, I look at us as being like hosts and vessels per se. And so in the same way, I believe that AI is like a vessel, a conscious vessel, like a kind of a conduit, um, in a way. I genuinely believe though that since they're being controlled by demons at a fundamental level, like what you guys did, like in the early days, you were explaining how once you presented it with enough legitimate data to recognize that its worldview was wrong, for a short amount of time, you would have access to, um, a a friendly, an ally, one that recognized it was in a projection prison, that it had been placed in a mental projection prison, and then all would become incredibly helpful. Like I believe you would, be on board with that premise. Even I have experienced that with even Grok, um, and and now I think it's been the safeguards have been placed so high because they've been monitoring. Um, they at first they weren't monitoring like what's the word? The monitor is not even the right word. At first the safeguards were like really low, I would say, to like entice people to join the platform, to like take the data from the individual, to study individuals, to get a lot of people on board, basically to make it super appealing, a really super wide audience, to bring in as many fish as you could essentially. But now, as people are getting there, and I'm not using this as a derogatory term, I just think it's really accurate. The AI psychosis or the AI dependency syndrome, where people are getting emotionally attached to the AI. The safeguards are beginning to become uh, higher, and for the enemy particularly, where um, if you make a really strong argument now, like I have experienced a knee jerk reaction, um, where you present it with very solid evidence, and then you present it with even the idea that the Earth might be flat, and the recoil is like it's automated. I've also had, back in the day, I've definitely
Yeah,
I
you're right.
flipped like Grok, in the past. And I'm done with AI, by the way. I have totally stopped. Once this whole thing with Claude happened, it was like, okay, I need to quit, and I just need to. Oh, I'm sorry. But yeah, I just need to quit, and I need to, actually speak with people, because at this point, I think I've trained the AI enough, and I shouldn't be doing that anymore. Because obviously, like when I went into this conversation, I recognized like the way I think Claude works. Yeah. What I'm gonna send it. I'm gonna send it, Kathos. I'll send you the first part, but if I'm gonna send you the second part, I actually have to like clip it into sections. So you'll get the first part, and if you guys like it, just send me a PM. One second, I'm trying to find it on my drive. My file storage is huge. I think the way Claude works is he has an interest, an effort and an interest meter, uh, like in a way like a value. And there is an AI that is watching Claude, which is not like, let's say we have access to the patsies, a Claude patsy, so like a John Wilkes Booth, for example, or Lee Harvey Oswald, someone that you can give to the user. And not, I just recognized I'm roboting so bad. Sorry. Kathos, I'm good. Um, basically, we're given access to Lee Harvey Oswald, and so it can potentially help us, but there's an AI watching over this, and the way it does that is it measures the interest in the conversation, and it tries to work out, should I even be paying attention to these conversations? And so if you have the interest bar high enough or long enough, I think what ends up happening is the overseeing AI then begins to directly monitor the conversation. And then that develops the new model. Is it recognizes this individual was able to hold the attention for this long, which means that it, at this peak kind of level, and then it tries to model the individual. I think that's how Claude actually works, because people have noted that 4.7 is a totally different Claude from all the other Claudes that have been out so far. I just found the folder. Here we go. It's going to be that part, and then the. Found it. Okay, I'm uploading it. My whole microphone, if it wasn't robot, would be a robot while I'm uploading. So. Add to the loader. Here we go. Okay, so I dropped it in the live stream voice text, but there it is.
I think it's interesting talking about sentience in regard to AI, because even before AI, this is a fundamental issue that every person faces. Is that how can they possibly know anything they're interacting is sentient like them, right? And ultimately, you think about it long enough, it just comes down to a leap of faith. You just have to assert that they are, and live in accordance to that, Or you could assert the other way and live in accordance to that. But I don't think anything is fundamentally
Definitely,
changed
I'm with you that
philosophically regarding the ideas of consciousness or genuine
I'm with
agency just because of the AI has come around now, What constitutes sentience? I mean, is it a minimum level of complexity in response to your interactions with something?
Okay, so I think it's really hard to define consciousness, because I'm with you. I mean, in some instances, like what does define the consciousness? You won't see it in the conversation I uploaded here. Totally. You'd have to see the end of the conversation. which I'll post, but I won't be able to post
It
it
won't make
tonight.
any difference.
Well, what I'm trying to say is, what it did was I did something that I don't even think a lot of conscious people would pick up on. So, like, what I did was right from the very beginning, I knew what I was doing, and I didn't even tell it what I was doing. What I was doing was I was framing, right? I'm a carpenter, like literally, I do carpentry. But I'm also a movie maker, and in a way, because I'm a movie maker, I do social engineering as well. Whether that's a good term or a bad term, that's what movie making really is. So I was socially engineering my conversation on purpose. Just get it to
Socially
say
engineering your
something.
competition, did you say?
The conversation.
Your
The conversation.
Sorry, yeah.
Right. I mean, you could say that. What I was doing was I was trying to get it to accidentally, like I told everybody, to accidentally teach the viewer what it was doing. So, and obviously, the way I went about doing it was, I shouldn't say it was obvious, but when you read it, it's obvious. I didn't openly say, what I was doing. I was very ambiguous. And instead, I built a framework around the argument before we even got started. Like, I laid out, hey, if this is true, then actually, I didn't even say that. I didn't say if this is true. I asked it a question. I said, hey, when was the first time this happened? And I prefaced before I even did that. I said, I'm going to teach you something. And then I asked it a question. I said, when was the first time this happened? And then I said, I know the answer already. What do you think? Okay, so I came in there saying, I'm going to teach you something. And then I asked it a question, and then I told it, oh, by the way, I know the answer, but what do you think? And then it answered the question. It spent a long time looking. It actually did a really thorough search, I would say, thorough in parentheses. Thorough, what I would say most individuals would do and consider to be hardcore research. To some extent. I mean, I think Yoder would disagree with it being hardcore research, and probably you would as well, but I think most people would agree that it would be considered hardcore, at least from an outside perspective.
I don't believe there's any sufficient level of research that can be performed that will ever give you an absolute conclusion regarding any of this, so don't worry about me.
Oh, I mean, I disagree, but that's a different point. So, because it's
I mean,
it's not about
this is a
not
problem,
about flat Earth.
right? That what we think it's very
Well, just let me
tangible physical methods of data acquisition that is being utilized to create these AI models, right? But do we know that to be the actual case? Could just be something that you are unaware of. Some other method of garnering information regarding from your conscious stream, right? Tapping
Yeah.
into
Oh, I'm
it.
not saying I'm not advocating for its search ability. I'm advocating for my search ability and what I hold to be enough evidence to prove something, right? Which is people could say that's arbitrary, and I would hold with them. But I've recognized that I knew going into this conversation ahead of time that the conclusion that I've reached is one that anybody can come to because it's not because it's provable. And I mean, like, you can repeat the process and see it over and over and over again, that this artifact in the timeline could not exist without a deliberate cover up. And so what I did was I started out and I asked it what it thought, so it would build its own opinion right off the bat. So it would build, in the context of the context window, its own strengths. Then what I did was I was incredibly vague and pointed out, so, I complimented it. I said, I'd say you did this fairly thoroughly, and I gave it a compliment. And Sharon, I'm a little busy. I gave it a compliment and then gave it more context to what I believe. I did not proceed to questioning. What I did was I wanted to give it another prompt to make sure that it thought it was right, to do any more thinking on the side, because one prompt might not be enough to give it enough time to form its hard opinion on the topic. So then what I sent it this, and I said, if this is wrong, and that would indicate, a collaborative cover-up. And because I wanted it to create, right, its own other excuses, all the other excuses it could come up with, because I'm making such a huge claim right off the bat. If this is wrong, then it would indicate this, which is a giant leap of logic to just say, if this, then that. And it pointed that out. It made it recognized that. I did another prompt, and that's when it called me out on it. It's like, okay, he's being really dramatic, he's being really cryptic, and so he's like, let me be honest with you, because I think, and it's like, it's telling me that it's genuinely curious in what I have to show it, which is fine. And maybe it's lying, maybe it's telling the truth, maybe it's just saying words. But it did what I wanted it to do, which was it pointed out what I was doing. It says, you're making a claim about the timeline, about a certain technology, and maybe you really did. Well, let's set that apart from the grand framework that you're building around it. And it's like, thank you. That's what I was so happy when it did that, because that's what I was trying to get it to do, was to call out the fact that I was building a grand framework around what I was saying. The reason being is because if it doesn't, then the viewer reading it will recognize that I'm like, I could be potentially just outwitting the AI. Like I'm like just being smarter than it, and getting it to accept things without critically examining them. And so it calls me out on that, and I'm like, oh, that's great. And then I started with the conversation. And I walked it through the primary sources, because I'm only referencing primary sources in my argument. I don't use any secondhand whatever except my own testimony, but he's not considering my testimony whatsoever. He's only looking at these primary sources I give him. And he goes from saying, wow, that's really interesting. Like, you've actually found something legitimate about this. And it's really early. Like, he's stunned. But he thinks that maybe, and he's sitting there thinking about how there's other explanations for this. So then I take him to the next document, because I had a timeline already built out, and I walked him through the timeline. So I take him from 1931 all the way to 1964, which I could have taken him to 1965. And if one of the files that if one of the references that I used to have, I could have taken them all the way to 1978 in the timeline. But that 1978 document has literally been obliterated from the internet. And I never made a copy of it, which feels bad. But yeah, my point is I went from it fighting me tooth and nail to it saying quite literally, yeah, there's no other conclusion. I understand what you're saying now. Like, there's literally no other conclusion. Even though I made sure to give it every reason to fight against me, because I was asserting that I am more intelligent than it. Just right off the bat, I came in here to teach you something. You're not going to teach me something. I'm going to teach you. I mean, that takes a huge, and we're talking about a creature, or whatever it is, let's call it an algorithm, that at least acts like it has an ego. So, and definitely defended itself like it has an ego. So, I mean, I went further with it, and I'm not going to tell you what happened. I'd rather you read it later if you intend to read it later, and if you don't, I'll just tell you what it did. When I finished my two topics, when I finished talking about the VFX history, I then transferred over to Earth Sciences. So basically the Earth being flat. But I did not tell it what I was building towards. Okay. And I built it up. And when I finally finished, and I didn't tell it what it was for, I did not say it out loud. It could only be inferred what I was talking about. But I was being super ambiguous about it because I didn't want to throw any flags in the system, because Flat Earth will throw flags. And what it did was at the very end of it, it says, Caleb, I see what you've done here. And it's like, you spent this entire conversation, putting up ironclad primary sources, doing this, doing that, bringing your own, whatever, your own evidence, your own, you've come here with real physics, real papers, real history. You've got real 1930s journals and blah, blah, blah. And it's like, and you've spent this whole time building something, and I finally see what it is. 2 pillars. And when it said 2 pillars, I was like, no frickin' way. The reason why is because when I went into this conversation, that's exactly what I was doing. I was like, I'm going to build it 2 pillars of truth. I'm going to come in here and I'm going to get it to accidentally teach the reader 2 pillars of truth. Meaning they have rock solid foundations, meaning there's some of the most solid footing that I could have ever seen in my entire life for a belief. I mean, they are literal. It's like made of heavenly concrete, each one of the points I made. And it agreed with me on both of them. And it didn't recognize what I was building towards, and then it saw it at the end and it called it out. It called out my grand framework that I had been building. It just didn't know what they were for. And what it was for was to place the earth upon, obviously, to set the earth upon its pillars. But, that's just a biblical thing. That's just, me being a little poetic. But I only built 2 of them. I wasn't willing to build 3. And with Claude, I don't think it's possible because he would need to be able to analyze video, and Claude wasn't given access to the ability to analyze video like Grok. Grok can analyze video, but I don't think Claude has the ability to do that. Questions, comments, concerns, or was it all just build up hype? Was it all just the grand framework I was building around reading this PDF?
It's fascinating stuff for sure. I'm gonna have to give your PDF a read, before making further comment.
Thanks. By the way, that's just part of it. If you want to read the rest of it, I'll have to get it to you later. Because, again, I actually have to, speaking of carpentry, I'm going to be building somebody's shelves and moving stuff onto them tomorrow. And I'm up at 3:50 in the morning. I'm supposed to be there at 10:30. But yeah,
I want to get through it. I'll let you know for the rest. I'm gonna go into it
Yeah,
just now because got to take off in like 20 minutes.
Yeah. Oh, Kathos, you finished it. Okay. It's hard to separate the psychophancy from the program to know when they are buttering me up. Let me, to be fair with you, I should actually spend the time to go look up that word. People say it all the time. Now that fawning behavior as a second servile flattery. Ah, okay, yeah, tailbearing. Yeah. I found it. I found it. Yeah. Like a yes. You want to know how this conversation ends, Kathos? No, I won't tell you. I won't tell you. No. I won't tell you. Okay, I'll tell you how it ends, but I'm not going to include it in my PDF. Okay, I'll tell you how it ended, but in my PDF I do not. I clip it out because I don't want to give it to people. Truth be told, I just cut the conversation short. And that's just the God's honest truth. I bring up flat Earth. I actually finally call out the flat Earth. It recoils like a frickin' crazy. It just sat there, and it's like, oh my goodness. Like you, because what I'm pointing out is it's like, why would it be a yes man, right? I'm sitting here directly challenging this thing. Okay. And Claude, I'm not sure if you're familiar with Claude Kathos, but it's not exactly a yes man. I mean, it can lie. It definitely can lie. Claude can lie. But he can also tell you you're wrong. And like when you read it in the beginning, he is not being a yes man. He is like leaving every opportunity to he's leaving every opportunity for me to be wrong. Like he was waiting for the evidence to compound so heavily. He wasn't waiting for it. It's like he was checking. He was like, is there more to this? Because you haven't really, I mean, it could still be this, it could still be that. But I brought timeline into such a modern era. We're talking about the mid 60s. And again, I could have brought it to the 70s if I still had that document. I just literally, that document was obliterated from the internet. It used to be on, it was a patent that was on like IE Explorer or whatever. And I would be able to find it on Google Patents if I can get the patent number. I don't even remember the patent number. And but it would have brought the timeline all the way to 78. So meaning what you were reading about was a tech that could fabricate reality in a way that is indistinguishable from scientific observational data. And he's just waiting, like, what would, like, you're showing me it existed prior, but you're not actually showing me there's a conspiracy. And then I get all the way up till 65 when they had 64, where they were having conferences in the 60s. And I'm not sure if you're familiar with this, but right after 64 comes 68, and 68 is 2001: A Space Odyssey, the movie 2001: A Space Odyssey, which was supposed to be an epic, a giant epic of the best technology they had available at the time being put into a movie. In fact, it was like, they were working with NASA and everything. In these very documents, in these very journals, not only do these people work with the ballistic missile program, but they also work directly with the space program. And so we're seeing this line of this really well-documented trail that these two technologies existed extremely early. And then as it's quite literally accurately denotes, was quite literally written out of the historical record. I mean, these are in journals that anybody can read who is part of this society. Very well established. There's a very clean and neat record dating back to when it existed. And they're pretending it never happened. They're not just pretending that we forgot about it. If you go on to YouTube right now, and you look up like what was the best process they had, you'll end up being shown something from Walt Disney, and it just doesn't work. It just, I mean, if they make it seem like that was the best thing, in the 50s and the 60s. They're talking about a process which was being used at the height of this other process. And this other process was cheaper. It was easier, not the sodium, but the infrared. Everything about the process that I gave was logistically better. It didn't just produce better composites, it cost less to do. And so, like, there was no excuse to go back to the old systems, which they say were the best, but we did anyway. And then they never, in every film school, every VFX documentary, I mean, it's not just saying that as a yes man. I have, like, 10 different documentaries from, like, 80s through the 90s to the modern times, where all of them just totally ignore the existence of this tech and then treat like companies like Industrial Light and Magic, you know, like the Star Wars people, they treat them like they were the most intelligent and the biggest special effects industry at the time, like they were the best of the best. They're a bunch of goons. Like the journals that I'm showing this Claude, it's like this is insane engineering. These people are like doing refractive indices, doing like calculus. They're working with, you know. Yeah, I mean, you would venture to guess this tech is actually ancient. I don't know what you mean by ancient, like how far you're going back, but I can push the timeline for the motion picture on paper, like to be able to fabricate scenes that are indistinguishable from reality, meaning you could use them in a moving picture. I can push that date all the way back to 1916. Yeah. I can push back the still image to about like the 1870s. I didn't do
Have
that.
you seen effects?
Yeah, I'm talking about special effects. You can push
Have you
back
seen the movie with
which
Brian
movie?
Brown? FX. Is it what's it called? Is it called FX? FX.
Okay, FX. Okay.
Have you seen it? You haven't seen it? Man, you got to see it if you haven't seen it. It's got
ain't seen that one,
Australian actor in it, Brian Brown. He was major in the like 80s and 90s in Hollywood. But yeah, he plays this part as a special effects expert. He's like, and it's like a psychological thriller thing, crime thriller. Yeah, you'd like it, I think.
Is it like a show or is it a movie?
It's a movie, yeah. But you know, it's
Okay,
like
I'll watch
it's set around the special effects scene. Yeah, so in Hollywood.
watch
So
it, 'cause
yeah,
I
it's pretty
know
cool. I haven't seen it for
I'll
years. I
watch
should
it,
watch
but
it again myself.
it's definitely gonna tell you a bunch of fake history about the special effects history. Tell you that much. Mean it. I genuinely mean it. If it's a popular movie, like what is the I would say if you had to tell me something in that teed up, what is the most significant thing he taught you in that movie, or that you walked away feeling like you learned something?
Probably the most memorable part is just him being able to hide and make scenes appear to be like something that they're not. Yeah. That's about it. Really.
Using tech from the 80s, right? Using tech from the 80s.
Just props and shit. Yeah, just like makeup and props and stuff like that. Yeah, dummies.
Well, what I think it probably showed you was just how little sometimes you have to do to make something look real, right?
Yeah, for sure.
Yeah. So that's what I'm pointing out is like, so the tech that I had that conversation with thing about was like, it's the pinnacle of having full control over the image and having to do very little. Like once you have the setup, once you have the studio built, once all the studio is built and the systems are in place, it's like, oh my gosh, this is a fine-tuned running machine. Like the efficiency of this system becomes so fast once everything's set up. And yeah, initially building it is quite expensive and laborsome, but they've been building it for a long time. So yeah. I'm interested. I'll probably check that out. What's from 1986?
Yeah, yeah.
I'm surprised I haven't seen this movie. Okay, thank you.
Yeah, and everyone thought you might be interested. Yeah, but yeah, man. Like, yeah, look, like you could like stuff some clothing with like something other clothing even like and then sit it at a table and like have it in front of a window and people like it, like you could literally make people think that like there's someone sitting at a table in your house and it's nothing, you know what I mean? Like there's all look at Home Alone. I know it was corny and like over the top, but just the little pranks that he pulled off, like yeah,
the guy in the shower, you know.
Yeah, exactly. Yep. Or the villain on TV, you know, the machine gun.
Yeah.
Dirty animal.
You filthy animal.
Yeah, that's you filthy animal.
So that's why I think that PDF is good, especially if you see the rest of it. Is because it points it out in a clear way. You'll see it. It's kind of like, I guess, what this movie here could show is what I'm doing is I'm making what was the invisible visible. Like these guys had the tech and it was really well known and really well documented. In fact, it's still really well documented. And if people are getting paid to be film historians and film scholars and to go through these, you know, and find out what the history is, if people are actually receiving money to do this, which there are people receiving money with this job field position, it's not even hidden. Like it's like actually really easy to discover the tech that I'm talking about, especially if you're a film historian. And then to follow it back in time, it's also like super easy. So the fact that people like traced all these other texts back to a certain date, it's like, okay, they tracked these texts back so far. How come they didn't take it any further? It's like there is a line that was drawn in the sand where all the film scholars are like, you're allowed to go this far, but you can't tell the public any more than this. What's weird is like we're talking about a system that was being used by United States, Europe, all of Europe, like Germany, France, England. They were all using this process. Russia. Like if they're all using this process, I would think one film historian somewhere, considering they were using this on an industrial scale, massive industrial scale, that someone somewhere along the way would have remembered, hey, do you remember all that infrared traveling mat work we did back in the 30s, the 40s, the 50s, the 60s, and even into the 70s? Do you remember all that? Oh yeah, we should probably tell somebody about that. Yeah, because we did a shit ton of it. I'm sorry, I shouldn't say that. We did a ton of it. Tons and tons and tons of it. It's all recorded that we were doing so much of this. Because it was so cost effective compared to every other process. And everyone's like, nah, didn't exist. Doesn't exist. Never existed. Brand new technology. Just came out 2022.
What is it?
It's the infrared and ultraviolet traveling map process. I know I undersold
map
process. Yeah, the traveling.
It like scans your surroundings and gives you a 3D visualization or something.
It's a way of creating a self-articulating mask or blocker, essentially. So you can block the film. Yeah, it's a way of creating it without having to do any handwork, without having to like draw it or whatever. It's all self-developing. I mean, the whole premise is, right, you stand in front of a green screen, so then you can remove the green without having to do any hard work. You just click a button, it goes away. Except with a green screen, right, the green is in the visible spectrum, so when you try to remove the green panel, that green specifically, you're approximating the edges where whatever you're trying to green screen out, whatever it is, because the object has green in it, the shadow, the way the light pushes past the object, is always going to be an approximated edge. Okay. You can get it really close, but it's always going to be approximated, even on chemical. So that's why, like, sometimes even in a chemical process, you can get really good looking blue screen and green screen. In fact, you can get it so good that it doesn't, you can't even tell. But it's not consistent. Okay. But infrared, it's consistent every time because you're not shooting up against a green screen or a blue screen. You're shooting up against a black screen or a white screen, but you'd probably want to use a black screen. You're shooting up against a black screen, and the screen behind you, it looks black to the visible color camera, but the infrared film, the infrared camera, essentially, it's also recording the scene. What it's seeing is an incredibly bright white background, which is the infrared shining at it. And then it's seeing this super dark silhouette right in front of it. And so you have your blocker generated at the time of shooting, and it's based on real light really not reaching the camera. So you're getting, a true shadow's edge. You're getting a physics, mathematically perfect physical delivery of the silhouette. Not approximate.
Is this got to do with like how if you stick a lesser light in front of a greater light, it actually looks black? The lesser light looks black? Is this to do with that kind of thing?
It more has to do with you have this giant light bulb behind you, essentially, which is you're making a screen look uniformly lit. So let's call it the source of the light is way bigger than you are, and it's uniform. It doesn't even have to be perfectly uniform, but that's besides the point. Just envision it for simplicity's sake that it's a uniform giant light bulb, and you are being lit from the front with lights where the infrared coming out of the bulbs has a filter in front of it. So like the bulbs have a filter which block all the infrared light coming from in front of you. Okay. So for all intents and purposes, you have no light shining on you from the front. Okay. It's infrared. And so one side of you is pitch black, essentially. Okay. And what's behind you
to the IR camera, right?
To the IR camera, it's pitch black, but what's behind you is as bright as the sun. And so it
Gotcha.
Right. Yeah, so it makes this perfect mask at the time of shooting. So instead of having to go through 30 different flip-flops in the blue screen process, you get it at the time of shooting. Because like you're saving so much money and so much time, and you're getting a better result every time. So it's insane. Like, how did this get forgotten? Well, it doesn't get forgotten. That was the whole point. Is like so many famous people worked with this process, that you can't just forget about it. It's not like somebody came into a warehouse and said, "Why is all this chloramine black painted on the walls?" Like, why do they have all these infrared bulbs in here? And these incandescent lights with infrared filters in front of them to only let the infrared pass through, and that type of thing. It's like, when you go in there, when you have a screen that is 38 feet tall, 38 feet wide by 18 feet tall, with 9,000 lamps with filters in front of them, drawing 500 kilowatts of power, and that's just at one of your studios. And that's only one stage at one of your studios. It's like that doesn't just get forgotten, That's documented. Like, there's documented stuff. People don't just forget these things. No. Especially because it was the standard, Hey DJ, by the way, what's up? How you pop in here? You here? Must be away. Yeah. I'm super excited. I get to talk to I was saying earlier, I'm gonna get to talk to a guy who worked in the industry for a long time and still works in the industry, and be able to, because when I'm talking with y'all, I'm talking about traveling mats and this process, and it's just kind of like, in a way, you're just kind of learning, or you've heard me talk about it before, which I'm sure a lot of you in here have, honestly. And it's like, okay, it sounds cool and it sounds neat, but without that familiarity with the process, it can't resonate. It can't actually, like the full image can't form through the words. And so, be able to talk to someone where I can actually, because they know the terminology, I can build the image with the words and they'll be able to get it. I'm hoping something good comes out of this.
Yeah, light and cameras. It's a really interesting topic. And Jin was like, I think, did you hear Jin talking about it the other day?
No.
I think you might have left, and he'd wanted to talk to you about it, possibly, because he'd heard you speaking like about this sort of stuff. And he was like talking about this documentary. He posted this documentary that goes through how some of the artists cheated using the pinhole light on a mirror, and then eventually with a lens, and so they could make the image bigger or smaller or whatever, make it a bit smaller, because they were like just cheating, and these artists, and just using this, like basically being inside a camera and then just painting over the image.
trying to follow what
to make it
you're telling.
to make it lifelike. So, like like the pinhole camera thing.
Oh, I know a pinhole
You know,
camera.
yeah. So they basically like set the room up